Imagine waking up one morning and the first thing you notice is that the lights won't turn on. You go to check your phone, but it's completely dead, and the usual buzz of the internet is nowhere to be found. Your TV doesn't work, the radio is silent, and you can't even find any connection to the outside world. No emails, no news updates, and no social media posts. It's a nightmare scenario that sounds almost impossible, but what if it actually happened? What if all of the world's electricity just shut off overnight? The truth is, we're so used to the constant hum of modern technology that we rarely stop to think about what would happen if it suddenly disappeared. The world runs on electricity. From the lights in our homes to the traffic lights on our streets, to the devices we use every day. Almost everything we rely on depends on electricity, and if it suddenly stopped, chaos would set in very quickly. In the first moments, it might seem like a temporary glitch, maybe a power surge or an unexpected outage that'll be fixed by morning, but as hours turn into the day, it will become clear that this isn't a simple issue. Imagine the panic that would spread as people realize that it's not just one neighborhood or one city or even one country. It's the whole world. Every single electrical grid has gone offline, and no one knows why or when it will come back. Now, the initial concern would be something simple. How do we stay warm or cool depending on where you live? Without power, heating systems and air conditioning would stop working, making homes uncomfortable or even dangerous. And that's just the beginning. Everything we use to stay connected, informed, or entertained is powered by electricity. Without it, we would be cut off from each other, left in the dark both literally and figuratively. Phones, radios, and the internet wouldn't work, and we wouldn't be able to access news or even communicate with people outside our immediate area. The world would feel as if it suddenly shrunk, leaving people isolated and vulnerable. The ripple effect of losing electricity would spread far beyond just our homes. Water treatment plants rely heavily on power to filter and pump water. Without it, millions would lose access to clean drinking water, putting communities at serious risk of disease and dehydration. Hospitals, emergency services, and other critical infrastructure would be crippled. No electricity means no functioning medical equipment, and no power for the staff that keep them running. Ambulances wouldn't be able to respond to calls, and first responders would be stretched thin with little to no resources at their disposal. Things would escalate fast. As hours pass without power, things would begin to take a more serious turn. The quiet panic that started to spread early on would grow into full-blown confusion and frustration. Without electricity, we'd begin to notice how much we truly depend on it for everyday life. For example, our food supply chains would be hit hard. Refrigeration and freezing are essential for keeping food from spoiling, but without power, food in grocery stores, warehouses, and homes would start to go bad quickly. What seemed like a temporary inconvenience could soon turn into a life-threatening situation as people scrambled to find ways to preserve food or secure fresh supplies. The transportation systems, which are vital to keep cities running, would also come to a halt. Without power, trains, subways, and buses wouldn't run. Traffic lights would stop working, turning major intersections into chaotic, potentially deadly gridlocks. Drivers would be forced to make their way through a maze of stalled vehicles and confusion. Air travel would be grounded as well, as airports depend on electricity to operate everything from check-in counters to the flight control systems. With the whole world's transportation network shut down, getting goods and people from one place to another would become almost impossible. Communities would start to notice the lack of communication. Without access to the internet or phones, people wouldn't be able to share information or coordinate with others. In larger cities, this could cause significant problems. Residents isolated from loved ones wouldn't know if their families were okay, and first responders would have no way to call for backup or relay crucial information. Those who had been planning to head out of town for vacation, business, or emergencies would find themselves stuck as no forms of travel or transportation were working. Plans and routines that relied on the steady flow of electricity would come to a halt, and life would quickly shift from what we know to a more primitive form of survival. Meanwhile, the simple conveniences that we once took for granted would be gone. No air conditioning on a hot day, no heaters in the middle of winter, and no ability to power essential devices like phones or laptops. People would be forced to rely on other means of communication like handwritten notes, while basic utilities like hot water would be out of reach. Over the next several days, many would struggle to adjust. As temperatures dropped or soared, depending on where you live, staying comfortable would become an increasing challenge. And while this might be uncomfortable for some, it would be far more dangerous for those with medical conditions that require electric-powered equipment, like ventilators. People who are already vulnerable in society, including the elderly and those with limited mobility, would be at risk of serious health issues or even death. As time stretched on without electricity, it would become clear that things would not return to normal anytime soon. In the first few days, people would hold on to hope, believing the outage was just temporary. But as that hope began to fade, the mood would turn darker. People might begin to panic or even resort to desperate measures as their access to food, water, and medicine dwindles. The systems that were put in place to keep societies functioning would start to collapse one by one. With no power to manage them, water treatment plants would stop working. Communication would be cut off, and hospitals would quickly become overwhelmed with patients unable to receive proper care. People would have to adapt, but the clock would be ticking and the sense of chaos would continue to build. As the days turn into weeks, the true consequences of a world without electricity would become even more apparent. The initial shock of the outage would give way to a harsher reality, one that would force people to adapt to a new, unfamiliar way of life. With no power, the conveniences we've grown so accustomed to, like the internet, television, and modern forms of entertainment, would vanish. People would have no choice but to go back to older forms of entertainment, like reading books, playing board games, or engaging in face-to-face conversations. However, with no electricity, the sense of isolation would grow stronger. People would struggle to find ways to pass the time, and in places where food supplies were running low, there would be fewer options for people to maintain their physical and mental health. Yet, during this time, one of the most significant challenges people would face is the lack of clean drinking water. Without power, water treatment plants would shut down, leaving millions of people without access to the clean water they rely on for survival. At first, people might try to use bottled water, but once stores run out, the situation would worsen. In many areas, people would have to resort to finding alternative water sources, such as rivers, lakes, or even rainwater, but this would carry its own set of risks. Contaminated water could lead to widespread illnesses, and access to clean water would quickly become one of the most sought-after resources. Communities would begin to organize to find safe ways to collect and distribute water, but it wouldn't take long before tensions started to rise, as the race for this essential resource grew more desperate. In major cities, the lack of power would bring more severe problems. People would still need to go to work, and businesses would still need to open. But without electricity, the usual systems for managing these operations would break down. Offices, stores, and factories would be forced to close, resulting in lost income and widespread economic turmoil. The global economy would grind to a halt, leaving people without the resources they rely on for daily life. The financial consequences would be devastating, and without power, it would be impossible to conduct business as usual. People would start to realize that this wasn't just a temporary inconvenience, but a shift in the very fabric of society. One of the most significant challenges people would face in a world without electricity would be the loss of medical services. Hospitals depend on power for life-saving equipment like ventilators, dialysis machines, and incubators. Without electricity, many of these essential services would be rendered useless, putting countless lives at risk. People who rely on electric-powered medical devices would find themselves in a critical situation. The healthcare system would be overwhelmed, and with no way to communicate with doctors or hospitals, many would have to rely on their own survival instincts to stay alive. The absence of power would also lead to an increase in medical emergencies, as people living with chronic conditions would be unable to get the treatment they need. As the weeks go by, some communities might start to come together to survive. People would share resources and rely on each other more heavily. It's likely that neighborhoods would bond in ways that we haven't seen in modern times, as people look out for each other and do what they can to make it through. However, as the days wear on, the lack of resources would create tension, food would become increasingly scarce, and the social order we take for granted would begin to erode. As desperation set in, some would resort to violence, looting, or taking extreme measures just to survive. Those with means or resources might try to leave for safer places, but the lack of transportation would make this nearly impossible. Communities would begin to form factions, and the social fabric that we've worked so hard to create would start to fray. With each passing day, the reality of life without electricity would force people to rethink what's truly important. Basic survival would take precedence, and long-term plans would be put on hold. People would focus on finding food, clean water, and shelter, and they would begin to understand just how fragile the systems we rely on are. But this situation would also lead to an opportunity for growth. As people adjusted to this new life, there would be a return to simpler times, a time when people relied on their resourcefulness and communities to survive. There would be a chance to rediscover skills and strengths that modern life has made us forget. But no matter how people adapted, the world would never be the same. The loss of electricity would be a reminder of just how dependent we've become on technology and how vulnerable we are when that technology disappears. As the months roll on, the situation in a world without electricity would become even more dire. By now, the novelty of a life disconnected from technology would wear off, and people would begin to realize the long-term implications of living in such a drastically altered world. Food supplies would continue to dwindle, and people would be forced to rely on whatever they could grow, hunt, or scavenge. This would lead to the rise of small, self-sustaining communities that would focus on agriculture, bartering, and survival skills. Some people might have learned how to grow their own crops, while others might have turned to hunting or fishing to make ends meet. But the reality is that without electricity, our agricultural systems would break down, making it harder and harder to produce enough food to sustain the population. The lack of electricity would also lead to an energy crisis, with people scrambling to find ways to generate power. Solar panels, wind turbines, and other renewable energy sources would become essential for survival, but not everyone would have access to them. Those who lived in rural areas or had the means to set up off-grid systems might have an advantage, but for most people, power generation would still be an issue. This would be especially challenging for those who live in urban areas, where the infrastructure is designed to rely on a constant flow of electricity. Urban centers without power would become ghost towns as people moved out in search of food, water, and a way to survive. As the world continued to adjust to the new normal, the breakdown of society would take a toll on mental health. People would struggle with the psychological effects of living in a world without the conveniences and comforts of modern life. Anxiety, depression, and despair would become more common, and without the ability to connect with others through technology, many would feel isolated and alone. People might try to organize in small groups for emotional support, but the constant stress of survival would wear people down. As time passed, the very essence of human civilization would change. Communities would become more insular, and the concept of trust would be redefined. In a world without electricity, every day would be a fight for survival, and it would take everything people had to keep going. At this point, the idea of restoring power would become a distant hope. People would still wonder if electricity would ever come back, but as the years dragged on, the chances of that happening would become slimmer. Governments and large organizations would struggle to get the systems back up and running, and the complexity of rebuilding power grids, communication systems, and infrastructure would be a massive undertaking. The financial and human resources required to restore everything would be nearly impossible to gather in the absence of a functioning economy. The global population would shrink and society would regress, reverting to simpler ways of life that rely on the most basic human skills: farming, hunting, and cooperation. But even in the face of such devastation, humans would find a way to adapt. Over time, society would rebuild itself from the ground up. The loss of electricity would force humanity to rediscover the importance of community, resourcefulness, and sustainability. The survivors of this new world would create new systems, new ways of living, and a new understanding of how to thrive without the technology that once defined their lives. But it would be a hard road ahead, one where every day would require a reminder of how much we took for granted in the world we once knew. It would be a world in which the need for electricity is no longer a convenience but a distant memory, a world where survival would take precedence and the lessons learned from this global catastrophe would change humanity forever. And in that future, the question would still linger: would we be able to build a better world from the ashes of the old one? Or would we fall back into the same patterns of over-reliance on technology, forgetting the lessons of the blackout that nearly destroyed civilization? One thing is certain: the world without electricity would forever change the way we see the world and the way we live in it. The story of this new world would be one of resilience, struggle, and the enduring human spirit. It would be a world where survival is the only thing that matters and where humanity would learn the true meaning of self-sufficiency. Join me as I dive into a wild hypothetical scenario and explore what would actually happen if Earth's spin suddenly stopped. It's something we don't even think about in our daily lives, but Earth is constantly spinning. Right now, as you sit and watch this, our planet is rotating at an incredible speed of about 1,000 miles per hour at the equator. We don't feel it because everything around us, our atmosphere, oceans, and even us, is moving at the same speed. But what if, in an instant, that rotation came to a complete stop? The immediate effects would be nothing short of apocalyptic. First, everything that isn't physically attached to the Earth would keep moving at the same speed the planet was spinning before. That means people, cars, buildings, trees, and even the oceans would be hurled eastward at terrifying speeds. The further from the poles you are, the more extreme this effect would be. Near the equator, people and objects would be thrown forward at speeds that would make survival nearly impossible. This sudden halt in movement would trigger massive earthquakes across the entire planet. The Earth's crust is always shifting because of tectonic movement, but this would be on another level. Fault lines everywhere would rupture at once, releasing unimaginable energy. Cities would crumble instantly, and the impact would be so great that even areas not near major fault lines would experience violent tremors. And then there are the oceans. Right now, Earth's rotation helps keep water levels relatively stable, with the centrifugal force causing the oceans to bulge slightly at the equator. If the planet stopped spinning, that water would have nowhere to go but toward the poles. The sudden redistribution of the world's water would result in devastating mega tsunamis. Entire coastlines would be swallowed up as water surged uncontrollably in all directions. Low-lying areas would be completely submerged within minutes, leaving no time for escape. The sky itself would turn into a disaster zone. While Earth's surface would come to a stop, the atmosphere wouldn't. The air would keep moving at the same speed as before, thousands of miles per hour in some places. This would create winds stronger than any storm ever recorded. These wouldn't just be hurricanes, they would be atmospheric shock waves tearing apart everything in their path. Buildings would be ripped from their foundations, forests would be flattened, and anything above ground would be blown away instantly. And this is just the beginning. As we move forward in this thought experiment, things get even worse. The loss of rotation would completely alter the way the Earth functions, affecting its climate, magnetic field, and even its ability to sustain life. In part 2, we'll dive into what happens next, the long-term consequences of a planet that has stopped spinning and what it would mean for our survival. As the initial shockwaves from the Earth's sudden stop start to settle, we begin to see some even more long-term effects. While the immediate chaos would leave the planet in ruins, the consequences of no longer having a rotating Earth would be felt far beyond the first few moments. One of the biggest changes would be to the planet's atmosphere. Without rotation, Earth's atmosphere wouldn't be able to function the way it does now. Currently, the rotation of the Earth creates the Coriolis effect, which helps steer winds and ocean currents. Without it, the atmosphere would essentially stagnate. The winds we rely on for weather patterns, from gentle breezes to massive storm systems, would become almost non-existent. The planet would no longer have the smooth, predictable weather systems we know today. Because of this lack of atmospheric movement, things would get incredibly extreme. Without the Coriolis effect to help regulate temperature, we'd have an even more severe difference between the equator and the poles. Imagine this. One side of the Earth would be stuck in perpetual daylight, while the other would be plunged into constant night. Without the day-night cycle, one half of the planet would be scorched by the sun, causing temperatures to soar to unbearable levels, while the other half would plunge into freezing cold, possibly creating an ice age-like environment. This imbalance would be devastating for any form of life. The ecosystems that depend on specific climate conditions would collapse. Without the usual distribution of sunlight, most plants would struggle to survive, disrupting food chains and threatening the survival of animals and humans. Entire species that rely on daily or seasonal rhythms would fail to adapt, leading to mass extinctions. Another huge change would be the Earth's magnetic field. Right now, our planet's core is spinning, and this motion generates the magnetic field that shields us from harmful solar radiation. If the Earth stopped rotating, the core would slow down as well, causing a dramatic shift in the magnetic field. This would make the Earth vulnerable to solar winds, which could strip away the atmosphere over time. With no protection, radiation levels would rise, making life even more challenging, if not impossible. At the same time, the oceans would be in chaos, with the oceans no longer held in place by the centrifugal force of the Earth's spin. There would be massive flooding along the coasts, but also extreme stagnation further inland. The lack of ocean currents would disrupt marine ecosystems, throwing the entire oceanic food chain into turmoil. Some areas might become lifeless, while others could experience rapid, unchecked growth, leading to new forms of extreme and unpredictable marine life. The loss of Earth's rotation would also have an impact on the planet's geology. Earth's spin helps to stabilize the planet's interior, influencing the movement of tectonic plates. Without rotation, plate movements would become even more unpredictable. This could cause more frequent and stronger earthquakes, along with volcanic activity as the planet's internal dynamics shift. The crust would continue to adjust to the sudden changes, leading to more land upheavals. So far, we've talked about the environmental chaos, but the social and human impact would be even worse. In addition to the immediate destruction of cities, the long-term consequences would cause a breakdown of society. Food production would come to a halt because of the changing climate and lack of stable ecosystems. Energy systems would be knocked offline, and communication systems would fail. Life as we know it would cease to exist, not because of a single catastrophic event, but because the planet would be unable to maintain the conditions necessary for life. Next, we'll dive even deeper into what would happen to the Earth's ecosystems, animal life, and the global human population. Stay tuned as we continue to explore the aftermath of Earth's sudden stop and the devastating effects it would have on everything living on it. Now that we've covered the catastrophic changes to the atmosphere and the planet's general environment, let's take a closer look at how life on Earth would cope with the sudden loss of rotation. The Earth's ecosystems, from forests to oceans, depend heavily on the movement of the planet. Without rotation, the delicate balance of nature would collapse, and the impact on both wildlife and human life would be devastating. One of the most noticeable effects would be on plant life. Plants depend on the Earth's day-night cycle to regulate their growth patterns. Without a rotating planet, one side of the Earth would be in constant daylight, while the other would remain in endless darkness. The plants on the day side would face extreme heat, potentially causing them to wither and die under the harsh sunlight, while those on the dark side would freeze, unable to carry out basic photosynthesis. Without plant life to sustain herbivores, the entire food chain would begin to break down. The lack of plant life would directly affect the herbivores and carnivores that depend on them. As plants die off or struggle to adapt, herbivores would have little to eat. This would lead to widespread starvation and the collapse of many animal populations. The carnivores, in turn, would lose their food sources, further compounding the crisis. This disruption in the food chain would eventually result in mass extinction across all ecosystems, from forests to grasslands to oceans. Speaking of oceans, they would face their own set of challenges without the Earth's rotation. With no more ocean currents to keep water moving, certain areas would become stagnant and the ocean's temperature would rise unevenly. Some parts of the ocean could become unbearably hot, while others would freeze, causing entire marine ecosystems to collapse. The loss of the Coriolis effect would prevent upwelling, which brings nutrients from the ocean floor to the surface, further depleting marine life. One of the most surprising changes would be in the animal migration patterns. Many species of birds, mammals, and even insects rely on Earth's rotation and the day-night cycle for navigation during migration. With no rotation, these animals would be lost, unable to find their way to breeding grounds or feeding areas. This could lead to the collapse of entire migratory species, further straining ecosystems that rely on them. The food web would be completely thrown off balance, with ripple effects felt across the planet. Humans would not be spared from the fallout of Earth's sudden stop. Our own survival would be at risk as our civilizations, already reeling from the initial destruction, would face a collapse in food production, medicine, and infrastructure. Without plants to produce oxygen and food, and with oceans in chaos, agriculture would be almost impossible. The loss of wildlife would also impact humans, as we rely on animals for both food and other resources like clothing and medicine. Even more devastating would be the breakdown of human society. Communication systems would fail without the satellites in orbit, and electrical grids would be knocked offline. In a world where technology has become an integral part of daily life, this would send humanity into a dark age. No longer able to rely on modern conveniences, society would struggle to adapt to the harsh, unpredictable environment. People would fight for dwindling resources, and survival would become the primary concern. As if this weren't enough, the sudden loss of Earth's spin would cause major health issues for humans. Our bodies are adapted to a 24-hour cycle, and the disruption of this rhythm would throw off our circadian rhythms. This would lead to extreme sleep disorders, mental health crises, and even physical health problems, as our bodies would no longer function properly in such an extreme and unpredictable environment. By the end of all this, the planet would become a shadow of its former self. The ecosystems would be shattered, life would be struggling to survive, and humanity would be on the brink of extinction. Earth's sudden halt would turn our home into a desolate wasteland, one that might take centuries or even millennia to recover from. As we move along, we'll explore what would happen if life on Earth somehow managed to adapt to these extreme changes. Would any species survive? And could the planet ever return to a state where life could thrive again? Stay tuned as we continue our journey through this unimaginable scenario. Now that we've looked at the immediate devastation caused by Earth's sudden stop, let's consider what might happen if, somehow, life on Earth began to adapt to these extreme conditions. Would there be any hope for recovery, or would the planet be permanently doomed? While the challenge seems insurmountable, there are a few possibilities that might allow life to continue in some form, although it would look radically different from anything we know today. First, let's think about the surviving species. Some animals and plants might find ways to endure the harsh conditions. Life on Earth is resilient, and throughout history, organisms have survived in extreme environments such as deep in the ocean, near hydrothermal vents, or in the frozen tundras of the Arctic. In the face of no rotation, it's possible that some species might adapt to the new extreme environment, but the chances of large-scale survival are slim. The key to survival would be adaptability. In the immediate aftermath of the Earth's stop, only the hardiest species, those able to survive without the rhythms of the day-night cycle, might manage to make it. Some animals, like certain insects, are known to be able to adjust to drastic changes in their environment. However, the lack of food sources would pose an even greater challenge. The collapse of ecosystems would leave very few places for organisms to thrive. Still, in isolated pockets, life might find a way to persist. The harsh frozen poles would become almost inhospitable, while the permanently sunlit side would scorch everything. However, some areas might be able to sustain new forms of life, as the Earth would likely undergo a transformation where a few ecosystems could emerge in niches. These survival zones might form in the places closest to the boundary between night and day, where temperatures might be more manageable. But even in these areas, life would have to cope with extreme conditions. The creatures that manage to live here would likely evolve to adapt to very long days and nights. So with no rotation, the Earth's atmosphere would be drastically different. Winds would no longer follow their usual paths, making weather unpredictable. The usual currents of the oceans would cease, causing temperature imbalances. It's likely that new weather systems would form over time, ones that are driven by the differences between the permanent day side and the permanent night side. But these new systems would be violent and unpredictable. Tornadoes, hurricanes, and superstorms could emerge in regions where hot and cold air masses would collide in intense ways. Over the course of many generations, life might find ways to adapt to these violent systems, but the immediate future would be extremely unstable. What about the possibility of human survival? If humans were able to adapt to such extreme conditions, the world as we know it would be completely different. Communities would likely have to relocate to these survival zones where they would need to build shelter to protect themselves from the unrelenting heat on one side of the planet and the freezing cold on the other. These new human settlements would be isolated, dependent on any surviving plants and animals that might be able to withstand the extreme shifts in temperature and the broken ecosystems. Agriculture would need to be redefined. Without the consistent sunlight and rotation, traditional farming would be almost impossible. People would have to develop new ways of growing food, possibly relying on artificial light or creating completely new farming methods that could handle the altered conditions. Similarly, energy sources would need to be rethought. Wind power, solar energy, and hydroelectric power might all be drastically reduced or become impossible due to the unpredictable weather and lack of reliable water systems. If humans could adapt and form small, isolated communities, it's possible that some technology could be salvaged or rebuilt. In isolated pockets, people might create new ways to communicate or develop entirely new technologies. But this would depend on the availability of resources, which would be incredibly scarce. However, even with these isolated successes, the overall picture remains grim. The collapse of ecosystems and the massive loss of biodiversity would make it nearly impossible to rebuild a functioning global society. The Earth's environment would be so radically altered that it might take millions of years to recover. The Earth's ecosystems would need to go through a process of reorganization, and that could only happen if surviving species could adapt and evolve in new ways. But even then, it's unclear whether life could ever truly return to its pre-stoppage state. As the generations passed, some form of life might continue, but the Earth would no longer be a hospitable home for the species we know today. Life would have to adapt to an entirely new set of rules, and the planet's future would remain uncertain. Would life continue in some form, even if it could never return to what it once was? Or would Earth eventually become a cold, lifeless rock, left to drift aimlessly through space? As we wrap up, we'll discuss the ultimate fate of the Earth if the spin stopped forever. Could the planet survive this drastic change, or would it be the end for all life on Earth? Stay tuned for the final part of this thought experiment as we conclude our journey through this unimaginable scenario. As we reach the final part of this thought experiment, let's take a step back and consider the long-term fate of Earth. If its spin were to stop completely, would our planet ever be able to recover, or would it be doomed to slowly fade into a barren, uninhabitable world? First, let's think about what would happen in the long run, beyond the immediate chaos and destruction we've already discussed. The sudden stop of Earth's rotation would result in a drastic shift in the planet's structure. With no rotation, the Earth would no longer maintain its slight bulge at the equator, and its shape would eventually become more spherical, like a perfect ball. This change would take millions of years, but it would fundamentally alter the landscape of the planet. The lack of centrifugal force would cause shifts in the tectonic plates, and the world would continue to experience earthquakes as the land adjusts to the new equilibrium. In terms of survival, some life could persist in isolated regions, but it would no longer be the Earth we know. Over time, the planet would continue to cool, especially on the side that remained in perpetual darkness. This freezing side would become a vast wasteland, where temperatures would drop to unimaginable lows. The permanently sunlit side of the planet would become a scorched desert, where life could not survive. There would be no transition from day to night, no gentle cycle of light and dark that gives rhythm to life. Without that, Earth's ecosystems would collapse entirely. Species that depend on the day-night cycle to regulate their behavior would not survive, and food chains would be broken beyond repair. While it's possible that a few hardy organisms could adapt to this extreme environment, the number of species able to survive would be minuscule. The loss of biodiversity would be catastrophic. The ecosystems we rely on would be gone, and with them, the complex relationships between species that keep the balance of life intact. The once thriving planet would be reduced to a wasteland, where only the most adaptable and resilient life forms would endure. Humans, too, would struggle to survive in this new world. The collapse of ecosystems and the scarcity of food would make it difficult for humans to sustain themselves. With no day-night cycle, there would be no reliable way to grow crops, and the agricultural systems that depend on sunlight would be destroyed. The once predictable weather patterns would become chaotic and violent, making it nearly impossible for any civilization to rebuild. The global economy would collapse, and the human population would dwindle. Those few humans who managed to survive would likely form small, isolated communities, but they would be cut off from one another by vast stretches of inhospitable terrain. The world would be a shadow of its former self, and the possibilities for rebuilding civilization would be slim. As for the planet itself, the Earth would slowly continue to cool, with both sides becoming increasingly inhospitable. Over the course of millions of years, the atmosphere might thin out, and the oceans could freeze. Earth could eventually become another dead world in the universe, a barren, lifeless rock drifting through space. The impact of this drastic change would be felt not just on Earth, but on the entire solar system. Without the stabilizing effect of Earth's rotation, the orbit of the planet could become unstable over time. This could lead to more long-term effects, like changes in the gravitational interactions between the Earth and the Sun, which could further disrupt the stability of the solar system. In the end, the sudden stop of Earth's rotation would mark the end of life as we know it. The planet would no longer be capable of supporting the diverse ecosystems that exist today. It would be a grim future, one in which the once vibrant world we call home would become a cold, lifeless shell. So, as we conclude this journey through the hypothetical scenario of Earth's spin coming to a halt, it's clear that the consequences would be devastating. Life as we know it would be unable to survive such a dramatic shift in the planet's behavior. Earth would become a place of chaos, destruction, and eventual lifelessness. The importance of our planet's rotation cannot be overstated. It is what allows life to thrive, and its sudden loss would be nothing short of catastrophic. Thanks for sticking with me through this exploration of one of the most extreme thought experiments imaginable. I hope it gave you some insight into just how important the Earth's rotation is to the delicate balance of life. If you've enjoyed this video, don't forget to leave a comment with your thoughts on this crazy scenario. And of course, be sure to subscribe for more fascinating discussions on the mysteries of our world. Imagine looking at the news and seeing that Antarctica's vast ice sheets stretching across millions of square kilometers, have vanished overnight. The sheer thought is enough to send chills down your spine, but it's also a hypothetical that highlights the fragility of our planet. Antarctica holds about 60% of the world's freshwater, locked away in its ice sheets. If all that ice disappeared in an instant, global sea levels would surge by over 58 meters, swallowing coastal cities and radically reshaping continents. This sudden event would plunge the world into chaos, starting with immediate flooding. Major cities like New York, London, Tokyo, and Sydney would be submerged underwater. Entire island nations, including the Maldives and Tuvalu, would cease to exist. Coastal regions that support hundreds of millions of people would become uninhabitable within hours. Ports, trade hubs, and airports located near shorelines would be underwater, effectively cutting off vital supply chains and triggering a domino effect of economic collapse. The immediate human cost would be staggering. Hundreds of millions of people would lose their homes in a single night, becoming climate refugees with nowhere to go. Countries already grappling with overcrowding or economic hardship would face insurmountable challenges trying to absorb such a massive influx of displaced populations. The resulting humanitarian crisis would dwarf anything the world has ever seen, putting unbearable strain on international resources and cooperation. In addition to the destruction of coastal infrastructure, the sudden disappearance of Antarctica's ice sheets would wreak havoc on global weather patterns. Ice plays a critical role in regulating the planet's temperature by reflecting sunlight back into space. Without it, Earth's natural cooling system would fail, causing a rapid increase in global temperatures. This albedo effect, as scientists call it, would accelerate warming, making extreme weather events like hurricanes, droughts, and heat waves more frequent and intense. Rivers, lakes, and other freshwater sources would also face contamination from saltwater intrusion, making clean drinking water scarce in many parts of the world. Crops near coastlines would be destroyed, and fertile farmland could turn into salty wastelands. This would jeopardize global food security, driving up prices, and leading to widespread hunger and political instability. The impact wouldn't just stop at sea level rise and flooding. Antarctica's ice sheets also serve as a stabilizing force for Earth's tectonic plates. Their immense weight keeps the crust in balance. If that weight suddenly disappeared, it could trigger a cascade of seismic activity. Earthquakes and volcanic eruptions in regions near tectonic boundaries, such as the Pacific Ring of Fire, could become far more frequent, adding another layer of devastation to an already catastrophic scenario. The scale of destruction would be unimaginable, touching every aspect of life on Earth. This what if may sound like science fiction, but it underscores the very real consequences of ignoring climate change. In the next part, we'll explore the forces driving ice loss in Antarctica and how close we are to tipping the scales toward this apocalyptic reality. While the idea of Antarctica's ice sheets vanishing overnight may seem impossible, the forces driving ice loss are already in motion. To understand the threat, we need to examine the complex interactions between rising global temperatures, shifting ocean currents, and the delicate balance that has kept Antarctica's ice stable for millions of years. This part of the story focuses on what's fueling this slow-motion crisis and why the situation is more urgent than it appears. At the heart of Antarctica's ice loss is climate change, driven by the release of greenhouse gases like carbon dioxide and methane into the atmosphere. Since the beginning of the Industrial Revolution in the late 1700s, human activity has increased these gases to levels not seen in over 800,000 years. As a result, global temperatures have risen by more than 1 degree Celsius since the late 19th century, with significant consequences for polar regions. Antarctica's vulnerability lies in its geography. The continent is surrounded by a vast ocean, and its ice sheets sit atop both land and water. Warmer air temperatures are melting ice from above, but the more dangerous threat comes from below. Ocean currents, altered by climate change, are bringing warmer water into contact with the base of Antarctica's ice shelves. These shelves act as barriers, holding back the massive ice sheets behind them. When they weaken or collapse, the ice sheets can flow into the ocean, raising sea levels. One of the most alarming examples is the Thwaites Glacier, often called the Doomsday Glacier. Located in West Antarctica, it's roughly the size of the state of Florida and holds enough ice to raise global sea levels by over 3 meters if it collapses. In recent decades, the glacier has been losing ice at an accelerating rate due to warm water melting its underside. Scientists estimate that its collapse could begin within the next few decades if current trends continue. Beyond individual glaciers, Antarctica's ice sheets are destabilized by a feedback loop. As ice melts, it reduces the reflective surface area that bounces sunlight back into space, a phenomenon known as the albedo effect. Darker ocean water absorbs more heat, causing further warming and more melting. This self-reinforcing cycle means that once significant melting begins, it becomes increasingly difficult to slow down or reverse. Another factor compounding the crisis is the breakdown of ocean circulation systems, particularly the Antarctic circumpolar current. This powerful flow of water around the continent acts as a buffer, isolating cold Antarctic waters from warmer currents. However, as ice melts and fresh water enters the ocean, it disrupts this delicate balance. Changes in salinity and temperature weaken the current, allowing warmer water to infiltrate and accelerate melting even further. The potential for runaway melting isn't just a distant possibility, it's already visible in some regions. The Amundsen Sea, for example, has seen some of the most rapid ice loss in Antarctica, with several glaciers thinning by up to 9 meters annually. This rapid pace shows that large-scale ice loss can occur much faster than previously believed, raising concerns about how prepared humanity is for such an event. These complex dynamics reveal that Antarctica's ice sheets are not just melting, they're unraveling due to a perfect storm of climate-related factors. The situation is further complicated by the fact that much of the melting occurs in remote and inaccessible areas, making it challenging for scientists to fully monitor or predict the pace of change. Yet the warning signs are clear. Antarctica's ice sheets are approaching a tipping point, and their fate hinges on global actions to curb greenhouse gas emissions. In the next part, we'll delve into the ripple effects that this hypothetical collapse would unleash across ecosystems, economies, and societies worldwide. The impacts would extend far beyond rising sea levels, transforming the planet in ways we might not fully comprehend until it's too late. If Antarctica's ice sheets were to vanish overnight, the immediate aftermath would be catastrophic on a global scale. The most obvious and devastating consequence would be the dramatic rise in sea levels. Scientists estimate that the complete melting of Antarctica's ice could add roughly 60 meters to global sea levels. This would inundate major coastal cities such as New York, London, Tokyo, and Sydney, leaving vast regions underwater and displacing hundreds of millions of people almost instantly. The loss of Antarctica's ice would also create a domino effect across global ecosystems. Coastal wetlands, which act as natural buffers against storms and provide critical habitats for numerous species, would be submerged. These ecosystems are home to birds, fish, and countless other organisms that rely on the delicate balance of salinity and tidal patterns. Their disappearance would disrupt food chains and lead to a decline in biodiversity that could take centuries to recover. Marine ecosystems would also face significant disruption. The cold, nutrient-rich waters surrounding Antarctica play a critical role in supporting life across the Southern Ocean. These waters fuel the base of the food chain, sustaining krill populations that are essential to whales, seals, and seabirds. Without the ice sheets to regulate ocean temperatures and maintain the flow of nutrients, the entire marine ecosystem in the region could collapse, triggering a ripple effect through global fisheries and food supplies. Beyond ecological damage, the vanishing of Antarctica's ice would have profound effects on global weather patterns. The massive ice sheets act as stabilizers for the planet's climate system. Their loss would disrupt atmospheric circulation, leading to more extreme and unpredictable weather events worldwide. Hurricanes and typhoons could become more powerful due to warmer oceans, while prolonged droughts and heat waves would threaten water supplies and agricultural yields in many regions. The sudden addition of trillions of tons of fresh water to the oceans would also disrupt thermohaline circulation, a critical component of the Earth's climate system. This global conveyor belt of ocean currents distributes heat around the planet, moderating temperatures and driving weather systems. If disrupted, regions such as Europe could experience severe cooling despite overall global warming, while other areas like the tropics could become unbearably hot. Economically, the effects of such an event would be staggering. Coastal infrastructure worth trillions of dollars, including ports, power plants, and urban centers, would be lost. Insurance industries would collapse under the weight of unmanageable claims, and governments would struggle to rebuild or relocate entire cities. Global trade would grind to a halt as supply chains heavily reliant on coastal infrastructure are thrown into chaos. The humanitarian crisis would be unprecedented. Hundreds of millions of people living in low-lying areas, from Bangladesh to the Netherlands, would be forced to flee their homes. Refugee numbers would dwarf anything seen in history, straining resources and political systems worldwide. Competition for dwindling resources such as fresh water, arable land, and food could ignite conflicts, further destabilizing already vulnerable regions. Compounding these challenges is the potential release of ancient carbon stores currently trapped beneath Antarctica's ice. As the ice sheets vanish, vast amounts of frozen organic material could thaw and decompose, releasing methane and carbon dioxide into the atmosphere. This feedback loop would accelerate global warming, amplifying the crisis and making recovery even more difficult. The immediate and far-reaching consequences of this hypothetical event highlight how interconnected our planet's systems are. The loss of Antarctica's ice would not only reshape the physical geography of the Earth, but also challenge humanity's ability to adapt and survive in a dramatically altered world. In the final part, we'll explore what actions can still be taken to prevent such a scenario and how the lessons of today could shape the future of the planet. If the ice sheets of Antarctica were to vanish overnight, the aftermath would serve as a grim wake-up call for humanity, revealing both the fragility of our planet and the urgency of collective action. Such a monumental event would leave no aspect of life untouched, forcing humanity to confront the profound consequences of a dramatically altered Earth. One of the most daunting challenges in the wake of this disaster would be global displacement. Entire nations such as the Maldives and Tuvalu would cease to exist beneath rising waters, and countless coastal cities around the world would become uninhabitable. This would trigger the largest migration crisis in human history. Governments and international organizations would face the unprecedented task of resettling hundreds of millions of refugees, requiring new infrastructure, housing, and resources in already crowded and resource-strained regions. Without coordinated global efforts, competition for survival could lead to widespread unrest and geopolitical instability. In addition to displacement, the loss of Antarctica's ice would have irreversible effects on agriculture and global food security. Fertile farmland would be destroyed by saltwater intrusion as rising seas contaminate soil and freshwater sources. Coastal fisheries, already under pressure, would collapse due to ecosystem disruptions and changes in ocean temperature. Crops dependent on stable climates would struggle to adapt to extreme weather patterns, leading to food shortages and skyrocketing prices. Global hunger and malnutrition would become widespread, hitting vulnerable populations the hardest. The crisis would also lay bare the inequities in the world's ability to respond to such a catastrophe. Wealthier nations with more resources might adapt more easily by building seawalls, relocating infrastructure, and developing advanced technologies. However, poorer countries, often those contributing the least to global emissions, would bear the brunt of the devastation. Entire cultures, histories, and ways of life would be at risk of disappearing forever, highlighting the disproportionate burden carried by those least responsible for climate change. As the world grapples with these challenges, humanity would be forced to reconsider its relationship with the planet. A crisis of this scale would likely accelerate scientific innovation and global collaboration as societies unite to find solutions. Renewable energy technology would become an urgent focus, as reducing greenhouse gas emissions would be critical to preventing further climate catastrophes. Countries would have to move beyond short-term interests and work together to rebuild, adapt, and create systems capable of withstanding the new realities of a transformed planet. Furthermore, the disappearance of Antarctica's ice would offer valuable lessons about the long-term consequences of inaction. It would serve as an undeniable demonstration of how interconnected the planet's systems are and how deeply human activity impacts the natural world. This newfound awareness could inspire future generations to prioritize sustainability, conservation, and environmental stewardship in ways that have previously been neglected. The catastrophic loss of Antarctica's ice would also force a reckoning with humanity's role as caretakers of the Earth. It would demand a shift in mindset from exploiting resources for short-term gain to protecting the planet for future generations. The world would need to develop policies that prioritize resilience and equity, ensuring that no region or community is left behind in the effort to rebuild. In the end, this hypothetical scenario is a sobering reminder of what's at stake if we fail to act. Antarctica's ice sheets are not just a distant feature of the Earth. They are a cornerstone of the planet's stability. While the idea of them vanishing overnight is extreme, The ongoing and rapid loss of ice is a reality we must confront. By taking action now, humanity has the opportunity to mitigate the worst outcomes, protect vulnerable populations, and chart a course toward a more sustainable and equitable future. The choices we make today will shape the planet for generations to come, whether through renewable energy, conservation, or international collaboration. The steps we take can help ensure that the dire consequences of this scenario remain in the realm of what if rather than becoming our reality. Imagine waking up to the sound of howling winds, rain hammering against windows, and a sky that remains permanently dark. Days turn into weeks, but the storm never lets up. This isn't just another extreme weather event, this is the new reality. A superstorm that never ends, an unstoppable force reshaping life on Earth. For years, scientists have warned about the growing power of storms, but no one expected something like this. Climate change had already pushed hurricanes, typhoons, and cyclones to their limits, fueling stronger winds and heavier rains. Then, conditions aligned in a way that no one had ever seen before. A perfect storm formed, a system so large and intense that it became locked in place, endlessly feeding off the ocean's warmth and the atmosphere's moisture. At first, it seemed like a typical hurricane. Meteorologists tracked its path, governments issued warnings, and people prepared to evacuate. But days passed, and instead of weakening, the storm grew stronger. The eye of the storm, where calm conditions usually appeared, disappeared entirely. Winds reached speeds never recorded before, tearing through cities with relentless force. The storm surge pushed inland, swallowing coastal towns whole. Air travel came to a halt, ships were lost at sea, roads vanished under floodwaters. Millions of people tried to flee, only to find themselves trapped. As highways turned into rivers and bridges collapsed under the strain, emergency response teams were overwhelmed. Power grids failed, plunging entire regions into darkness. Food supplies dwindled as stores ran out of essentials, and farms were left in ruins. As days turned into weeks, scientists realized something terrifying. This storm wasn't going away. It had become self-sustaining, locked in a feedback loop that kept it alive. The planet's rising temperatures had created the perfect conditions for a never-ending storm, and without a way to disrupt it, humanity faced a future where the weather was no longer just unpredictable, it was unstoppable. As the weeks stretched on, the superstorm became more than just a weather event. It became a force of nature that reshaped the planet. The atmosphere, now permanently unstable, continued feeding the storm with warm air and moisture. Scientists scrambled to understand why it wasn't dissipating, but every attempt to predict its end resulted in the same answer. There was no end. With no sunlight breaking through the thick storm clouds, temperatures dropped in some regions, while others experienced an unnatural humidity that made survival unbearable. Crops failed as floodwaters drowned entire farmlands. Areas that relied on seasonal rain patterns faced a new challenge: too much water, too fast. The constant deluge washed away topsoil, turning fertile land into useless swamplands. Without agriculture to sustain them, supply chains collapsed and food shortages turned into a global crisis. Coastal cities suffered the worst. Massive storm surges swallowed entire neighborhoods, turning once thriving metropolitan areas into flooded wastelands. Saltwater intrusion contaminated freshwater supplies, leaving millions without drinkable water. Inland regions weren't spared either. Rivers overflowed, dams failed, and landslides buried towns under mud and debris. The constant battering of high-speed winds tore buildings apart, leaving behind skeletal remains of once strong structures. Governments struggled to maintain order, evacuations turned chaotic, as roads remained impassable and airports remained shut down indefinitely. Military forces were deployed for rescue operations, but even they were limited by the storm's relentless power. Satellites captured haunting images from space, an enormous, unbroken swirl of clouds covering vast portions of the Earth. It was no longer just a superstorm, it had become the defining feature of the planet's climate. With communication lines down in many regions, isolated communities were left to fend for themselves. In some places, the storm created permanent refugees, millions of people forced to abandon their homes, seeking shelter in underground bunkers, reinforced buildings, or any place that could offer even temporary protection. The world was rapidly changing, and for the first time in human history, civilization faced a battle against a storm that had no end in sight. As the superstorm persisted, the world's infrastructure faced an unprecedented collapse. Roads and bridges, weakened by unrelenting floods and hurricane-force winds, crumbled into the rising waters. Railways twisted and snapped, cutting off vital supply routes. Airports, once hubs of global travel and trade, became abandoned ruins buried under debris. Without functional transportation networks, delivering emergency aid to affected regions became nearly impossible. Entire nations were plunged into darkness as power grids failed under the stress of constant lightning strikes, fallen transmission towers, and waterlogged electrical systems. The lack of electricity created a new crisis. Hospitals, unable to sustain their operations, ran out of backup power. Life-saving machines shut down, and critical medications spoiled without refrigeration. The world's healthcare systems, already strained, collapsed under the sheer number of injuries, infections, and illnesses brought on by the storm. Contaminated floodwaters became breeding grounds for deadly diseases, spreading infections at a rate never seen before. With hospitals overwhelmed, survivors were left to rely on makeshift clinics, volunteer medical teams, or whatever supplies they could scavenge. Meanwhile, the Earth's geography itself began to shift. Entire coastlines disappeared as erosion accelerated, swallowing entire towns. Riverbanks widened unnaturally, permanently altering landscapes. Deserts, once arid and lifeless, saw unexpected storms carving deep canyons into their surfaces. Some mountain ranges faced continuous landslides, reshaping their terrain in real time. Scientists monitoring satellite data confirmed that the planet's weather systems had entered a state of permanent chaos. The psychological impact on humanity was staggering. With no sign of the storm weakening, hopelessness spread as fast as the floodwaters. Some communities turned to desperate measures, forming isolated enclaves and defending their resources against outsiders. Others abandoned their homes entirely, seeking shelter in underground facilities, abandoned subway systems, or deep caves. Governments, struggling to maintain order, enacted martial law in an attempt to stop widespread looting and violence. Despite the chaos, efforts to adapt began. Engineers worked on storm-proof structures designed to withstand constant battering. Scientists searched for ways to manipulate the atmosphere, hoping to break the storm cycle. Plans were made to construct floating cities, using advanced technology to create sustainable habitats above the floodwaters. Yet with resources stretched thin and survival the top priority, the question remained: was there any real hope of escaping a storm that refused to end? As the world adjusted to the reality of a never-ending superstorm, survival became a test of human resilience and ingenuity. With no hope of the storm dissipating, scientists focused on radical solutions to stabilize the atmosphere. Some proposed large-scale geoengineering projects, such as injecting aerosols into the upper atmosphere to alter weather patterns, or constructing massive ocean barriers to disrupt storm formation. However, these plans carried immense risks. Tampering with the planet's delicate climate balance could lead to even worse consequences. With much of the land rendered uninhabitable, new methods of living had to be developed. Some of the wealthiest nations and corporations invested in constructing self-sustaining floating cities. Designed to ride out the endless waves, these structures, built from advanced materials, housed entire communities, complete with hydroponic farms, desalination plants, and wind-powered energy sources. Those who couldn't access such technology sought refuge underground, carving out survival bunkers beneath mountains, inside abandoned mines, or in deep cave networks where the wind and rain couldn't reach. The superstorm had reshaped human civilization. Entire countries were abandoned, their once thriving populations either drowned, displaced, or forced to migrate. Old political boundaries became meaningless, replaced by scattered survival zones. Some nations, desperate to maintain order, became authoritarian regimes, controlling dwindling resources with an iron grip. Others collapsed entirely, leaving behind lawless wastelands where only the strongest survived. Amidst the chaos, a small but determined group of researchers continued to search for answers. Studying atmospheric data from the few remaining satellites, they noticed unusual patterns forming in the storm's structure. Some theorized that the extreme climate shifts had created a self-sustaining weather system, one that could only be disrupted by a dramatic environmental shift, perhaps the eruption of a massive volcano or a planetary cooling event. However, triggering such an event deliberately was dangerous and unpredictable. Despite the odds, humanity refused to give up. Survival became the only goal, and people adapted in ways once thought impossible. The world as it had been was gone, reshaped by the storm's wrath. Cities lay submerged, landscapes permanently altered, and the future remained uncertain. Yet as long as there were people willing to fight for survival, there was still hope, even in a world where the storm never ended. Imagine you get up and start your day only to find that the Earth's magnetic field had completely flipped overnight. It's a phenomenon that has happened before in Earth's long history, but never as suddenly as we're imagining here. The magnetic field is like an invisible shield around our planet, protecting us from harmful solar radiation and cosmic particles. It's also the reason compasses point north, and it plays a crucial role in navigation, communication, and even the behavior of wildlife. If this protective field suddenly flipped, the world as we know it would be thrown into chaos. The Earth's magnetic field is generated by the movement of molten iron and nickel in the outer core, located deep beneath the surface. This constant churning creates a dynamic force that extends out into space, forming what's known as the magnetosphere. While the magnetic poles have shifted many times throughout Earth's history, scientists estimate there have been hundreds of flips. The process usually takes thousands of years. But what if this change didn't follow its usual slow pace and instead happened in a single night? First, it's important to understand just how critical the magnetic field is to life on Earth. Without it, harmful solar particles would bombard the planet's surface, stripping away the atmosphere over time and exposing life to dangerous levels of radiation. While a sudden flip wouldn't instantly destroy the atmosphere, it would weaken the magnetic shield temporarily, creating vulnerabilities. Solar winds, those streams of charged particles from the sun, could penetrate much closer to the surface, causing disruptions that would be felt globally. This change wouldn't just stay in space, it would have immediate effects on the ground. As the magnetic field shifted, powerful electric currents would be generated in the Earth's crust and in the power lines above it. These induced currents could overload electrical systems, causing transformers to fail and power grids to collapse. Imagine sitting in the dark as lights go out not just in one city, but across entire continents. Modern life depends on electricity for everything from basic household needs to running hospitals, transportation networks, and communication systems. A sudden reversal would make these critical systems unreliable or even unusable. But it's not just technology that would feel the impact. Many animals rely on the Earth's magnetic field for navigation. Birds use it to migrate across vast distances, while sea turtles depend on it to return to the same beaches where they were born. If the field flipped overnight, these animals could become disoriented and unable to follow their usual patterns. Over time, this could lead to population declines as they struggle to adapt to the new magnetic reality. This scenario is as fascinating as it is unsettling. While we know that magnetic field reversals have happened in the past, we don't fully understand how quickly they can occur or what their immediate effects might be. What we do know is that the consequences of such an event would be widespread and deeply disruptive. In the next part, we'll explore how a sudden flip could create chaos in our skies, disrupt satellites, and alter the way we communicate and navigate our world. If the Earth's magnetic field were to flip completely and suddenly, one of the first areas to feel the effects would be our skies and the technology orbiting above the planet. The magnetic field plays a vital role in protecting our satellites from the intense radiation of space. These satellites are essential to nearly every aspect of modern life, from weather forecasting and navigation to communication and global commerce. A sudden reversal of the magnetic poles would throw this delicate system into disarray. Without the usual magnetic shielding, satellites in low Earth orbit would be exposed to heightened levels of radiation. Solar particles could interfere with their electronic components, leading to malfunctions or even total failure in many cases. This would disrupt GPS systems, which depend on precise satellite signals to provide accurate location data. Suddenly, airplanes, ships, and even cars would lose their ability to navigate reliably. Emergency responders and delivery services, which rely heavily on GPS for quick and accurate routing, would face significant challenges, leaving people stranded and supply chains in chaos. Additionally, the global communication networks that depend on satellites would be crippled. Everything from internet connections to international phone calls could be severely affected. Financial systems that rely on high-speed data, transfers between countries would experience interruptions, causing significant economic disruptions. Imagine trying to withdraw cash or process a credit card payment, only to find that the systems required to do so are offline. Businesses would come to a standstill and people would find themselves disconnected from the digital world they've come to depend on. In the skies, air travel would also face major challenges. Aircraft use magnetic navigation systems to help pilots determine their position and course, especially when flying over oceans or remote areas where other systems are unavailable. A sudden flip in the magnetic field would render these systems inaccurate, forcing airlines to ground flights until reliable navigation alternatives could be implemented. This would lead to delays, cancellations, and logistical nightmares for travelers and cargo alike. Solar storms, which are bursts of energy and charged particles from the sun, would pose an even greater threat in this scenario. Normally, the Earth's magnetic field deflects most of this energy, but a sudden reversal would weaken this protection temporarily, leaving satellites and power grids more vulnerable to geomagnetic storms. The effects of a powerful solar storm during this period could be catastrophic. Power outages would become more frequent and widespread, while electronic devices and systems could sustain permanent damage. These cascading failures would highlight just how interconnected our world has become and how dependent we are on the technologies that the magnetic field helps protect. In the next part, we'll take a closer look at how the natural world would respond to such a sudden flip, including the potential effects on wildlife and the environment itself. A sudden and complete flip of the Earth's magnetic field would profoundly disrupt the natural world, creating challenges for both wildlife and the environment. Many species have evolved to rely on the magnetic field as a guide for survival. This natural compass is deeply embedded in their behaviors, and its sudden reversal could leave them disoriented, leading to widespread ecological ripple effects. Migratory animals such as birds, sea turtles, and certain species of fish are particularly vulnerable. These animals use the Earth's magnetic field to navigate vast distances during migration, often traveling thousands of miles between breeding and feeding grounds. For example, sea turtles rely on magnetic cues to return to the exact beach where they were born to lay their eggs. A sudden magnetic flip could confuse these animals, causing them to lose their way and fail to reach critical habitats. This disorientation could disrupt breeding cycles, reduce population numbers, and threaten the survival of species already at risk. In the oceans, marine life dependent on magnetic navigation would face similar challenges. Some species of sharks, which use magnetic fields to hunt and navigate, could struggle to find food or migrate to their usual areas. Fish populations could shift unpredictably, creating imbalances in marine ecosystems and affecting the fishing industries that depend on them. Coral reefs, which support a diverse array of marine life, might also suffer indirectly as disruptions to the food chain ripple outward. Terrestrial animals that use the magnetic field for orientation, such as certain mammals and insects, would experience confusion in their daily behaviors. For example, some species of ants and bees, which rely on magnetic signals to find their way back to their colonies, could lose this ability. This disruption could affect pollination patterns, with cascading consequences for plant reproduction and agriculture. Beyond wildlife, the environment itself would be exposed to increased solar radiation during a magnetic field flip. The weakened magnetic field would allow more charged particles from the sun to penetrate the Earth's atmosphere, leading to changes in atmospheric chemistry. One immediate consequence would be damage to the ozone layer, the shield that protects life from harmful ultraviolet radiation. An increase in ultraviolet exposure could harm plant growth, particularly crops which are sensitive to changes in radiation levels. This could result in lower agricultural yields and exacerbate food shortages already strained by disruptions in technology and logistics. Regions closer to the poles, where the magnetic field is weakest during a reversal, would face the most significant environmental impacts. Aurora activity, commonly seen in these areas, would intensify and expand toward lower latitudes. While these dazzling light displays might seem beautiful, they are a visible sign of increased solar radiation reaching the atmosphere, which could bring harmful consequences. As the natural world struggles to adapt, human societies would feel the strain of these ecological shifts. In the next part, we'll explore the long-term impacts on climate and the cascading consequences for humanity in a world where the magnetic poles have completely flipped. If the Earth's magnetic field completely flipped, the consequences for our planet's climate and long-term environmental stability could be dramatic and far-reaching. While the exact relationship between magnetic reversals and climate change is not fully understood, scientific studies suggest that such an event could influence atmospheric conditions, ocean currents, and even weather patterns. One immediate concern would be the increased exposure to solar and cosmic radiation due to the weakened magnetic shield during the reversal process. As more charged particles penetrate the atmosphere, they could interfere with the formation and behavior of clouds. Clouds play a crucial role in regulating the Earth's temperature by reflecting sunlight back into space and trapping heat close to the surface. Disruptions to cloud dynamics could lead to shifts in temperature extremes, with some regions experiencing severe heat waves, while others might face unusual cooling. The increased radiation could also alter atmospheric circulation patterns, impacting jet streams and trade winds. These high-altitude wind systems drive weather patterns across the globe, and any changes could result in prolonged droughts, heavier rainfall, or unexpected storms in regions unaccustomed to such extremes. For instance, areas that are typically arid might experience flooding, while regions dependent on seasonal rains could face devastating water shortages. Ocean currents, another critical component of the Earth's climate system, could also be affected by a magnetic field flip. The movement of water in the oceans is driven by a combination of temperature, salinity, and the Earth's rotation, but magnetic influences on seawater conductivity might play a subtle role. Any disruption to these currents could destabilize the balance of heat distribution between the equator and the poles, leading to phenomena such as the intensification of El Niño and La Niña events. These shifts could exacerbate climate variability, affecting agriculture, fisheries, and coastal communities worldwide. Another potential long-term effect of a magnetic reversal is the impact on the ozone layer. As increased radiation reaches the upper atmosphere, it could deplete the protective ozone layer, allowing more harmful ultraviolet radiation to reach the Earth's surface. This would pose significant risks to human health, particularly skin cancer and eye damage, and harm ecosystems by affecting the growth and reproduction of plants and animals. Agricultural crops sensitive to ultraviolet exposure, like wheat and rice, could suffer reduced yields, putting additional strain on food supplies. The cascading effects on ecosystems and climate would ultimately intersect with human infrastructure and societies. Coastal cities, already vulnerable to rising sea levels and storms, might face even greater risks as unpredictable weather patterns intensify. Global supply chains dependent on stable conditions for transportation and production could be disrupted further, leading to shortages of essential goods and economic instability. As humanity grapples with these long-term changes, it becomes evident that a magnetic field flip is not just a scientific curiosity, but a phenomenon with profound implications for life on Earth. In the final part, we'll explore how humanity could respond to such an event and what steps might be taken to prepare for the challenges of a flipped magnetic field. In the event of a sudden magnetic field flip, humanity would face unprecedented challenges. While many of the effects would be gradual, the disruptions to daily life would start almost immediately. Power grids would be one of the first systems to be impacted, as the sudden surge of electrical currents in the Earth's crust could overload transformers and cause widespread blackouts. It's possible that, at first, society would struggle to adapt to these sudden outages, with basic services like water and communication networks becoming unreliable. One of the most crucial concerns would be the survival of our technology-driven world. Satellites, which play a critical role in communication, weather forecasting, navigation, and defense, would be severely damaged or even destroyed. This could leave nations isolated, cutting off access to critical information and preventing the ability to coordinate disaster relief or recovery efforts. Similarly, GPS systems, which we've come to rely on for everything from personal navigation to military operations, would no longer function, making travel and logistics much more difficult. In this chaotic environment, emergency response efforts would be stretched to their limits. The disruption of communication and transportation networks would make it harder for governments and relief organizations to mobilize quickly. People in affected areas would need to rely on old-fashioned methods of survival, such as direct contact with neighbors, community-based resources, and a heightened sense of local self-sufficiency. Countries would need to quickly adapt to this new reality, shifting away from global cooperation and trade towards more localized solutions. The scientific community would likely be at the forefront of efforts to understand and mitigate the effects of a magnetic field flip. Researchers would urgently work to find ways to shield sensitive electronics from increased solar radiation and develop new strategies for protecting infrastructure. Advancements in radiation shielding and space weather monitoring would become essential to safeguard the health of astronauts, pilots, and those living at higher altitudes, who would be more exposed to dangerous radiation levels. As the world adjusts, society would inevitably change. The reliance on technology for everyday life would have to be reevaluated, and a return to more traditional forms of communication and travel might emerge. People might return to using maps, compasses, and even basic radio systems, which would be unaffected by the magnetic reversal. This could spark a global renaissance of self-reliance and preparedness as communities begin to rebuild from the chaos. Though the challenges of a magnetic field flip would be enormous, they would also present an opportunity for humanity to grow and innovate. The event would force us to confront our vulnerability and rethink how we interact with the environment. While the immediate consequences would be devastating, the long-term recovery would require collaboration, ingenuity, and a deepened understanding of the planet's complex systems. As we've seen, the Earth's magnetic field is a key protector of life on Earth, and its sudden flip would test our resilience in ways we can only imagine. But it's essential to keep learning, studying, and preparing for all possibilities, even those that seem unlikely. The more we understand about our planet and its natural phenomena, the better equipped we'll be to handle whatever challenges may arise in the future. So, what do you think? Would humanity be able to adapt to such a monumental shift in Earth's magnetic field? The answer isn't clear, but one thing is certain. Understanding the science behind these events is more important than ever. Thank you for joining us on this journey, and if you want to dive deeper into the mysteries of Earth's phenomena, don't forget to check out our next video. Join me as I dive into the crazy scenario of what would happen if every volcano on Earth erupted at the same time. Imagine waking up one morning to a sky that is no longer blue, but an eerie, thick shade of gray. The sun is barely visible through the dense ash clouds that have begun to spread across the globe. The air is filled with a deep rumbling sound, a low vibration that rattles windows and shakes the ground. This is the beginning of the most catastrophic event in Earth's history, the simultaneous eruption of every volcano on the planet. To understand the sheer scale of destruction, let's first look at how many volcanoes exist worldwide. There are more than 1,500 active volcanoes on land, with an additional estimated tens of thousands located beneath the ocean. These underwater volcanoes, known as submarine volcanoes, make up the vast majority of Earth's volcanic activity. If all of them erupted at once, the first and most immediate effect would be a violent release of lava, ash, and toxic gases into the atmosphere. The force of these eruptions would send shockwaves across the planet, causing massive destruction before the full impact of the disaster is even realized. One of the biggest threats from a mass eruption would be the release of volcanic ash. This fine, glass-like substance is not just a visual nuisance, it is incredibly dangerous. Inhaling even small amounts can cause severe respiratory issues, and the sheer volume of ash released would make it nearly impossible to breathe in affected areas. Within minutes, airports would be forced to shut down, cars would become useless as engines clogged with ash, and buildings would begin to collapse under the weight of accumulating debris. This would leave entire cities in chaos, with millions of people trapped without access to transportation or emergency services. Beyond the immediate explosions and ash clouds, another catastrophic consequence would be the triggering of massive earthquakes. Volcanoes are closely tied to the movement of tectonic plates, and a simultaneous eruption would create intense seismic activity. Fault lines across the globe would be shaken to their core, leading to destructive earthquakes that could topple buildings, crack open roads, and even create giant fissures in the ground. Coastal regions would face an even greater threat as underwater, volcanic eruptions triggered enormous tsunamis. These towering walls of water would race toward shorelines at terrifying speeds, wiping out entire communities and leaving devastation in their wake. In addition to earthquakes and tsunamis, wildfires would break out across the globe as lava flows ignited forests and urban areas alike. The intense heat from the eruptions would cause temperatures to soar, making it nearly impossible to contain the spread of fires. This would add another layer of destruction as entire ecosystems burned and wildlife was forced to flee or perish in the flames. As terrifying as the immediate effects would be, the long-term consequences would be even worse. The sheer volume of gas and ash ejected into the atmosphere would block out sunlight, causing a phenomenon known as volcanic winter. With less sunlight reaching the Earth's surface, temperatures would begin to plummet. Crops would fail, leading to food shortages on an unimaginable scale. Without access to fresh produce, livestock would begin to die off, further straining the already collapsing food supply. Within weeks, famine would spread across the planet, making survival an even greater challenge. This is only the beginning of what would happen if every volcano on Earth erupted at once. The destruction would be swift and merciless, but the true test for humanity would come in the weeks and months that followed. As the planet struggled to recover, societies would be forced to adapt to a world that was no longer the same. In the next part, we'll dive deeper into the long-term environmental effects of this disaster and how it would shape the future of human civilization. Stay tuned as we continue exploring this mind-boggling scenario in the immediate aftermath of every volcano on Earth erupting at the same time. The planet would be plunged into chaos, but as the days turned into weeks, the long-term consequences would begin to unfold in ways that would reshape life as we know it. The sheer volume of ash, toxic gases, and debris ejected into the atmosphere would lead to devastating climate shifts, plunging Earth into what scientists call a volcanic winter. With sunlight struggling to break through the thick layers of volcanic ash covering the skies, global temperatures would start to drop rapidly. This effect, similar to what happened after the eruption of Mount Tambora in the early 19th century, would be magnified on an unimaginable scale. The cooling of the planet would disrupt seasonal weather patterns, throwing agriculture into complete disarray. Crops would fail across continents as photosynthesis slowed, leading to food shortages that would escalate into widespread famine. Livestock would struggle to survive as pastures became barren, and freshwater sources would become contaminated with sulfuric deposits from the relentless acid rain. The oceans would not be spared from the effects of this catastrophic event. The massive influx of volcanic material into the water would alter oceanic currents, disrupting marine ecosystems in ways that could cause the collapse of entire food chains. Coral reefs, already vulnerable to environmental stress, would be smothered by ash and toxic chemicals, leading to widespread die-offs. Acidification of the oceans would accelerate, affecting marine life from the smallest plankton to the largest predators. The air itself would become a threat to survival. Sulfur dioxide and carbon dioxide levels would soar, creating an atmosphere thick with poisonous gases. Respiratory illnesses would skyrocket, with many struggling to breathe in the heavily polluted air. Those without access to proper filtration systems would suffer from severe lung conditions, and the lack of medical resources would make survival even more difficult. Cities, already overwhelmed by the destruction from the eruptions, would become ghost towns as people fled in search of cleaner air and safer conditions. Amidst the chaos, societies would struggle to maintain order. With power grids severely compromised and transportation systems in ruins, communication between nations would become almost impossible. Governments would be forced to ration resources, but the sheer scale of the disaster would make coordinated relief efforts nearly unmanageable. As food supplies dwindled and desperation set in, conflicts over basic necessities would erupt, leading to civil unrest and breakdowns in law and order. Beyond the immediate survival concerns, the long-term effects on the planet's ecosystems would be profound. Entire species of plants and animals would face extinction as habitats were either destroyed by lava flows or rendered uninhabitable by the sudden climate shift. Forests would wither from a lack of sunlight, and the once green landscapes of Earth would turn into barren wastelands. Even if volcanic activity eventually subsided, the scars left behind would take centuries to heal. As the world entered the second month after the global eruptions, survival would depend on the ability to adapt to these new and brutal conditions. In the next part, we'll explore how humanity would try to endure in a world where the very air, water, and land have turned against them. As the second month passed and Earth continued to suffer the aftermath of every volcano erupting at once, humanity faced a brutal new reality. The volcanic winter had fully set in, and temperatures continued to plummet. With sunlight blocked by thick ash clouds, many regions experienced an early and intense winter, while others suffered from extreme storms triggered by the chaotic shifts in the atmosphere. What was once predictable seasonal weather had become erratic and deadly, with hurricanes, blizzards, and torrential rains sweeping across the planet. In major cities, survival had become nearly impossible. Without functional power grids, heating systems failed in colder regions, leaving millions exposed to freezing conditions. In warmer areas, acid rain and toxic air made outdoor survival just as deadly. People who had not evacuated early now struggled to find shelter, food, and clean water. Many underground bunkers and shelters, initially thought to be safe, were filling with toxic air seeping in from above. One of the most devastating consequences of this global disaster was the collapse of agriculture. By the third month, the lack of sunlight had completely halted photosynthesis in many regions. Crops withered and died, and soil, covered in volcanic ash, became too acidic to support new plant growth. The famine that had started shortly after the eruptions had now become a full-scale global food crisis. Nations with food reserves found themselves struggling to ration supplies, and black markets emerged as people desperately sought anything edible. Some turned to hunting wildlife, but animal populations had been just as affected by the environmental shift. Many species that couldn't adapt to the extreme conditions were already facing extinction. The oceans, which had already suffered from pollution and acidification, now became even more unstable. With sunlight unable to reach the water's surface, plankton, the foundation of the marine food chain, began to die off in alarming numbers. This led to the collapse of entire marine ecosystems. Fish populations dwindled, and coastal communities that depended on fishing for survival found themselves without a food source. Rising levels of toxic gases in the atmosphere also led to acid rain, further poisoning the water supply. Rivers and lakes became contaminated, making fresh water even scarcer than before. Societies had reached a breaking point. Governments that had managed to maintain some level of order in the first few weeks of the disaster were now overwhelmed. Global trade had completely collapsed, and many countries were forced into isolation, relying only on whatever resources they had left. Some regions attempted to form self-sufficient communities, but with so few resources available, conflicts erupted over food, water, and habitable land. Wars once fought over political and territorial disputes were now fought over basic survival. As humanity struggled to hold on, scientists and engineers worked desperately to find solutions. Underground farming experiments were being conducted using artificial lighting, but scaling them up fast enough to feed the population was nearly impossible. Filtration systems were being developed to remove toxins from the air and water, but access was limited and most people had no way of getting to these resources. Some had even begun to speculate about long-term survival options beyond Earth. But with space programs crippled by the destruction of infrastructure, any hope of escaping the planet was nothing more than a distant dream. By the end of the first year, the world was a vastly different place from what it had been before the eruptions. Humanity had been pushed to the brink, and survival was no longer guaranteed. But what about the long-term future? Would Earth ever recover from this catastrophe? Or was this the beginning of the end? In the final part, we'll explore what happens in the years that follow, and whether there's any hope for rebuilding civilization. A full year had passed since every volcano on Earth erupted at the same time, and the world had become almost unrecognizable. The once thriving cities were now abandoned ruins, covered in layers of thick, volcanic ash. The air remained toxic in many regions, forcing survivors to stay underground or within sealed-off shelters. The few remaining governments had collapsed entirely, leaving behind only scattered groups of people, desperately trying to stay alive. Civilization as it once was had ceased to exist. Despite the overwhelming devastation, Earth itself had begun a slow process of recovery. The initial phase of the volcanic winter had peaked, and while thick clouds of ash still filled the atmosphere, some regions had started to see faint glimpses of sunlight breaking through. This offered a small sign of hope, an indication that given enough time, the planet's natural systems might begin to stabilize. However, this recovery was not without its challenges. The climate had permanently changed. The average global temperature had dropped drastically, leading to what many now called a mini ice age. Entire regions that had once been warm and humid had transformed into frozen wastelands, while previously temperate zones experienced extreme, unpredictable weather patterns. With ocean currents disrupted, hurricanes and superstorms had become more common and more destructive, reshaping coastlines and further eroding whatever remnants of civilization remained. The planet's ecosystems had also shifted dramatically. With so much plant life wiped out and marine ecosystems in collapse, many species had gone extinct. The animals that had survived were those that could adapt quickly. Scavengers, burrowing species, and deep-sea creatures. Some forests had managed to withstand the disaster, particularly those in isolated areas where ashfall had been lighter. But for the vast majority of the planet, nature was in a state of rebuilding, much like humanity. The biggest question that remained was whether humans could adapt to this new world. Many had already succumbed to starvation, disease, and exposure, but the most resilient had found ways to endure. Underground farming operations, though small, had begun producing limited amounts of food using artificial light and controlled environments. Engineers had developed new ways to filter and purify water, ensuring that at least some clean drinking sources remained available. In isolated regions, survivors had created small, self-sustaining communities, relying on whatever resources they could find. Communication between groups was rare but not impossible. Some had managed to repurpose old technology, using radios to broadcast messages in search of other survivors. These efforts had led to the formation of larger networks where people pooled their knowledge and supplies, slowly working toward rebuilding some form of organized society. It wasn't the world that once existed, but it was a start. The long-term future of Earth remained uncertain. If the volcanic activity had triggered more deep-seated geological changes, future eruptions could still be a possibility. The planet would likely take centuries to fully recover, with ecosystems slowly regenerating and climate patterns stabilizing over time. Humanity, however, didn't have centuries to wait. Survival depended on adaptation, resilience, and a willingness to embrace a harsh new way of life. While the world as it was before would never return, the disaster had proven one thing. No matter how extreme the conditions, life had a way of continuing. Even in the darkest moments, humanity had refused to disappear entirely. The question was no longer whether Earth could recover, but whether people could find a way to thrive in this transformed world. Would humanity rebuild? Or was this the beginning of a new primitive existence where survival came before progress? Only time would tell. Rogue planets. Just the name alone sounds unsettling. These mysterious worlds drift aimlessly through space, unbound to any star, moving in complete darkness. Unlike planets in our solar system that orbit the sun in predictable paths, rogue planets are wild, unpredictable, and potentially dangerous. But what would actually happen if one of these rogue planets collided with Earth? Is this just a sci-fi nightmare? Or could it really happen? Let's dive into this terrifying scenario and break it all down. First, let's talk about what a rogue planet actually is. Scientists believe rogue planets are planets that were once part of a solar system, but got ejected due to gravitational disturbances. Maybe a close encounter with a larger planet, or a passing star knocked them loose. Without a star to keep them in orbit, these planets are left to drift endlessly through the cosmos. Some are smaller, like rocky Earth-sized planets, while others are gas giants, even bigger than Jupiter. The scary part? They're nearly invisible. Since they don't orbit a star, they don't reflect much light, making them incredibly difficult to detect. Now, could one of these rogue planets actually collide with Earth? The short answer: it's extremely unlikely, but not impossible. Space is massive, and Earth's orbit is a tiny target in the grand scale of the universe. But with potentially billions of rogue planets floating through the galaxy, the idea that one could eventually cross paths with our planet is still a possibility, no matter how small. So let's say, hypothetically, that a rogue planet is headed straight for us. How much time would we have to react? That depends on how fast it's moving and how soon we detect it. Since rogue planets don't emit their own light, they're nearly invisible until they get close. If a planet the size of Earth or larger were on a collision course with us, we might not even see it until it was only a few years or even months away. That wouldn't give humanity much time to prepare. Before impact, we'd start seeing some major warning signs. The gravitational pull of a rogue planet approaching Earth would start disrupting our own orbit. We might experience shifts in the tides, extreme weather changes, and even a slight alteration in the length of our days. If the rogue planet had its own moons, they could create additional gravitational disturbances, possibly affecting the orbits of other planets in our solar system as well. As it got closer, the night sky would change. What looked like just another star at first would grow into a massive looming object, bigger and bigger with each passing night. And then the real nightmare begins. Next, we'll dive into what happens the moment of impact, the sheer force of the collision, the explosion it would create, and the immediate destruction it would bring. The devastation would be unlike anything Earth has ever seen. The moment of impact would be unlike anything Earth has ever experienced. As the rogue planet closes in, the sky would be completely dominated by its massive form. It wouldn't be a slow collision. This thing would be moving at an unimaginable speed, likely tens of thousands of miles per hour. The sheer force of that much mass traveling so fast would release more energy than all the nuclear weapons on Earth combined. The impact itself would be an explosion on a planetary scale. If the rogue planet were similar in size to Earth, the force of the collision would likely crack the planet's crust open, sending molten rock and debris flying into space. A blinding fireball would engulf entire continents in seconds. Shockwaves would ripple through the atmosphere, flattening everything in their path. The impact zone itself wouldn't just be destroyed, it would be vaporized instantly. Mountains would be turned to dust, oceans would boil away, and anything even remotely close to ground zero wouldn't stand a chance. But the destruction wouldn't stop there. The force of the impact would send massive seismic waves racing through the Earth, causing earthquakes stronger than anything ever recorded. These quakes wouldn't just shake the ground, they would rip the planet's crust apart, creating massive fissures that could stretch for thousands of miles. Entire continents could shift, and some land masses might even sink into the ocean. Then come the tsunamis. If the rogue planet hit the ocean, the explosion would create waves so massive they would make even the biggest known tsunamis look tiny in comparison. These waves wouldn't just hit coastlines, they would travel inland for hundreds of miles, wiping out entire cities and reshaping the geography of the planet. Even landlocked regions wouldn't be safe, as floods and rising sea levels would follow. In the atmosphere, things wouldn't be any better. The collision would send trillions of tons of rock and debris hurtling into the sky, blocking out the sun and creating a choking, thick cloud of dust that would plunge the planet into darkness. The heat from the impact would ignite global firestorms, burning forests, cities, and anything else that could catch fire. The world would turn into a smoldering, ash-covered wasteland in a matter of hours. And then, the long-term effects would begin. As we move on, we'll explore what happens after the initial destruction, the devastating climate changes, the collapse of ecosystems, and the grim reality of what life, if any, could survive in the aftermath. After the initial chaos of the impact, Earth would begin to experience one of the harshest climates imaginable. The atmosphere, now filled with debris, would block out sunlight for months, even years. The planet would plunge into a prolonged darkness, triggering what's known as an impact winter. Without sunlight, temperatures would plummet worldwide. In many areas, the freezing temperatures would make it impossible for life to survive. The cold would be extreme, with some regions dropping well below freezing, even in the summer months. The Earth's climate would be thrown into complete disarray. Plants, which rely on sunlight for photosynthesis, would die off, crops would fail, and the already unstable ecosystems would collapse. Animals that depend on plant life for food would starve, and herbivores would quickly follow suit. Carnivores would face similar fates as their food sources would dwindle. This massive loss of life would disrupt the food chain entirely. Some species might be able to adapt in the short term, but many others would be wiped out. The Earth's biodiversity could shrink drastically, and ecosystems could take millions of years to recover, if they ever do. The air, already thick with ash and dust, would become toxic as chemicals from the impact seep into the atmosphere. The lack of sunlight would halt the process of photosynthesis, which would lead to a shortage of oxygen. Plants are a key source of oxygen on Earth, so without them, the planet's oxygen levels would drop dramatically, further endangering life. The absence of a stable atmosphere and the presence of these toxic gases could create a hostile environment for any remaining organisms. In addition to this, the Earth's magnetic field might be severely disrupted. The impact could shift the planet's axis, potentially causing erratic weather patterns, extreme seasonal shifts, and even making certain regions of the planet uninhabitable. A change in the tilt of the planet could also affect the day-night cycle, possibly making days much longer or shorter, adding to the already unstable conditions. The most terrifying aspect of this scenario is that these changes wouldn't be temporary. Even after the dust and debris begin to settle, the Earth would still be a shell of what it once was. The combination of the planet's severely damaged ecosystem, drastically reduced oxygen levels, and intense radiation would create a world that's nearly impossible to survive in. Any remaining survivors would face an extremely harsh, inhospitable reality. In the next part, we'll look at the possibility of life on Earth enduring this catastrophe, the long-term survival of humanity, and the potential for rebuilding in a world so drastically changed. The aftermath of a rogue planet collision would undoubtedly leave Earth in a state of chaos and near destruction, but what about the possibility of life hanging on? Could humanity or any form of life make a comeback after such a catastrophic event? While the future would seem grim, the concept of resilience remains a possible, though unlikely, factor in this nightmare scenario. For humanity, the surviving few would face an unimaginable challenge. Those who manage to survive the initial impact and subsequent extreme conditions would be forced into isolated, harsh environments, possibly underground or in specially designed shelters that could withstand the cold, lack of oxygen, and radiation. These shelters would be critical, as any remaining surface life would likely be unsustainable for long periods. The possibility of finding food would be near impossible, given the collapse of ecosystems. Any remaining crops would have been destroyed by the freezing temperatures, and the few animals left alive would be under intense pressure from the hostile environment. In terms of technology, humanity might have a chance to use what resources are left to rebuild. It wouldn't be a quick process, though. Even with the most advanced tools, the lack of resources, combined with the extreme environmental conditions, would make survival a constant struggle. The limited supplies of food and water would soon run out, and the lack of any meaningful trade or production would leave societies isolated, clinging to whatever was left of civilization. The loss of power, internet, and communication would make it impossible to maintain any form of global government or coordinated effort to recover from the catastrophe. Surviving in the aftermath of a rogue planet collision would also mean facing a planet that's unrecognizable. Earth's environment would continue to shift unpredictably with the lack of a stable ecosystem, making recovery even more difficult. If any plants or animals could adapt to the new brutal conditions, it would likely take thousands or even millions of years for them to evolve into something resembling life as we knew it before. The survival of humanity would depend on how well the remaining survivors could adapt to the changes and utilize the little they have left. The idea of a rogue planet hitting Earth remains a terrifying hypothetical, but it's one that serves as a reminder of how fragile our existence truly is. The universe is full of unpredictable forces, and though the chances of a rogue planet colliding with Earth are incredibly slim, the devastation it would cause is something we cannot ignore. This scenario pushes us to think about our place in the cosmos and reminds us that we must continue to study the unknowns of space to understand more about the dangers that may lurk beyond our solar system. With advancements in technology and space exploration, humanity might one day be able to detect rogue planets early enough to make adjustments. We're already making strides in detecting objects that could threaten our planet, and hopefully with time, we'll have the tools to prevent such a catastrophe. But until then, the thought of a rogue planet colliding with Earth is a chilling reminder of the vulnerability of life on our planet. Thank you for joining me on this deep dive into the possibility of a rogue planet hitting Earth. If you got any thoughts or theories of your own, I'd love to hear them in the comments. And if you're interested in more discussions on the mysteries of space and Earth's future, don't forget to check out my other videos. The Amazon rainforest is one of the most important ecosystems on Earth. Spanning across multiple countries in South America, it is home to millions of species of plants, animals, and microorganisms. It plays a crucial role in maintaining the balance of our planet's climate, water cycle, and biodiversity. But what if the entire Amazon rainforest were to burn down? What would happen to the environment, the atmosphere, and life on Earth? If a massive fire were to engulf the entire Amazon, the first and most immediate impact would be the sheer devastation of plant and animal life. The Amazon is home to over 3 million species of plants and animals, many of which exist nowhere else on Earth. A fire of this scale would wipe out entire ecosystems in a matter of days, causing irreversible loss of biodiversity. Thousands of species, from jaguars to rare insects, would either die in the flames or lose their habitats, leading to mass extinctions. The heat from a fire this size would also create an enormous plume of smoke and ash that would spread across South America and beyond. The skies would darken and the air would become thick with toxic fumes. This would pose a serious health hazard to people living in surrounding regions. The smoke could travel across continents, affecting air quality in other parts of the world. Respiratory illnesses would spike, and the reduced sunlight could even lower temperatures in certain areas temporarily, creating strange weather patterns. One of the most concerning effects would be the release of massive amounts of carbon dioxide into the atmosphere. The Amazon acts as one of the largest carbon sinks on the planet, absorbing and storing carbon dioxide from the air. If the rainforest were to burn completely, all of that stored carbon would be released in one catastrophic event. This would accelerate climate change at an unprecedented rate. Scientists estimate that the Amazon holds over 100 billion metric tons of carbon. Releasing this all at once would lead to a sharp increase in global temperatures, speeding up ice melt, rising sea levels, and extreme weather events worldwide. Fires of this magnitude would also disrupt the water cycle. The Amazon generates its own rainfall through a process called transpiration, where trees release moisture into the air, which then forms clouds and returns as rain. Without trees, this cycle would break down. Rainfall in the region would plummet, leading to widespread droughts, not just in South America, but in distant parts of the world that depend on the Amazon's moisture. Agricultural regions that rely on consistent weather patterns could face crop failures, leading to food shortages and economic struggles. The destruction of the Amazon would not only affect South America, but the entire planet. Its loss would set off a chain reaction of environmental disasters, some of which we might not even fully understand yet. The full consequences would unfold over time, making it clear just how much we depend on this vital rainforest. But this is just the beginning of the disaster. In the next part, we'll explore what would happen in the days and weeks following the destruction of the Amazon, and how the loss of this massive rainforest would continue to reshape our world. In the days and weeks following the destruction of the Amazon rainforest, the environmental effects would become even more severe. The immediate fires may have died down, but the long-term consequences would continue to unfold, impacting ecosystems, weather patterns, and even human populations worldwide. One of the first noticeable changes would be the dramatic shift in global weather. With the Amazon gone, the atmospheric moisture that once helped regulate temperatures and rainfall across South America and beyond would disappear. Large parts of the continent would begin drying out, leading to desertification in areas that were once lush and thriving. Countries like Brazil, Peru, and Colombia would experience prolonged droughts, severely impacting agriculture and water availability. Rivers that once depended on the rainforest rainfall, including the Amazon River itself, would shrink, affecting millions of people who rely on them for drinking water, transportation, and food. And without the Amazon's ability to trap heat and regulate temperatures, extreme heat waves would become more common, not just in South America, but across the globe. Regions that were already prone to high temperatures would see record-breaking heat, while areas further from the equator could experience sudden and unpredictable climate shifts. The loss of tree cover would also cause massive soil erosion, as the roots of the rainforest trees had previously held the soil together. Without them, landslides and dust storms would become more frequent, further damaging local communities. Another critical consequence would be the rapid increase in carbon dioxide levels in the atmosphere. While the initial fire released billions of tons of carbon, the absence of the rainforest would mean that this carbon could no longer be absorbed and stored. Global temperatures would begin rising more quickly than before, leading to an acceleration of climate change. Ice caps in Antarctica and the Arctic would start melting at an even faster rate, contributing to rising sea levels that could flood coastal cities worldwide. The disappearance of the Amazon would also disrupt ocean currents. The rainforest plays a crucial role in regulating air pressure and temperature, both of which influence oceanic weather patterns. Without it, shifts in wind and water temperatures could cause more frequent and intense hurricanes, typhoons, and monsoons. Places that typically experience mild storms could suddenly be hit by catastrophic weather events, leading to loss of life and destruction of infrastructure. The global food supply would also take a major hit. The Amazon's impact on weather patterns helps maintain stable agricultural conditions in multiple regions, including parts of North America, Africa, and Europe. Without it, farming conditions would become unpredictable, leading to crop failures, food shortages, and rising prices. Farmers would struggle to adapt to the rapid changes, and some regions could experience famine as a result. As the weeks go by, the damage would extend beyond nature, affecting human health and economies. With lower oxygen levels and higher pollution, respiratory illnesses would become more widespread. Hospitals would be overwhelmed, with cases of asthma and lung infections, especially in cities that were already dealing with air pollution. The economic impact would be devastating as well, as industries reliant on the Amazon's resources, from agriculture to pharmaceuticals, would collapse, leading to job losses and financial instability. The destruction of the Amazon rainforest wouldn't just be an environmental disaster, it would be a humanitarian crisis. In part 3, we'll explore what life on Earth would look like in the months following this catastrophe, and how societies would struggle to adapt to an entirely new world. Months after the Amazon rainforest is completely burned down, the The world would be in a state of environmental and societal crisis. By this point, the immediate fires and their thick smoke would have dissipated, but the long-term effects would be growing more severe. The planet would be struggling to adjust to the loss of one of its most important ecosystems, and the consequences would be impossible to ignore. One of the biggest changes would be in the atmosphere. Without the Amazon's ability to absorb carbon dioxide, global greenhouse gas levels would continue to rise at an alarming rate. This would lead to further warming, causing unpredictable and extreme weather events. Some regions would experience prolonged droughts, while others would be hit by record-breaking storms and flooding. The damage caused by these weather shifts would make it increasingly difficult for communities to recover, forcing many people to relocate as their homes and farmland become uninhabitable. Biodiversity loss would also reach a devastating scale. While the fires themselves would have wiped out countless species, the after effects would continue to impact wildlife. Many animals that managed to escape the destruction would struggle to survive in the altered environment. Without the dense vegetation of the rainforest, food sources would be scarce, and competition for resources would increase. Some species would migrate to new areas, but many would not be able to adapt quickly enough and would face extinction. This loss of biodiversity would have a cascading effect on ecosystems worldwide, as the Amazon's wildlife played a role in maintaining balance far beyond its borders. The loss of the Amazon's water cycle would also lead to significant changes in freshwater availability. Without the rainforest natural filtration system, rivers and lakes in South America would become more polluted and less reliable as sources of clean water. This would impact not only people in the region, but also global industries that rely on South America's water supply for agriculture and manufacturing. The lack of rain would further deplete reservoirs, making hydroelectric power generation more difficult. Countries that depend on the Amazon's water flow for energy would face electricity shortages, leading to economic instability and power outages. In cities worldwide, air quality would continue to worsen. While oxygen levels would not drop to dangerous levels, the combination of excess carbon dioxide and ongoing deforestation in other parts of the world would lead to increasingly poor air conditions. Major cities that already struggle with pollution, such as Sao Paulo, New Delhi, and Beijing, would see a rise in respiratory illnesses. Governments would be forced to implement emergency measures to control emissions, but without the Amazon's natural ability to regulate air quality, these efforts would be less effective. Another consequence of the Amazon's destruction would be its impact on indigenous communities. Many indigenous groups depend entirely on the rainforest for food, medicine, and shelter. With their land completely destroyed, they would be left without resources or a place to live. Some might attempt to integrate into urban areas, but many would face challenges due to the loss of their traditional way of life. Their knowledge of the rainforest plants and ecosystems, knowledge that has been passed down for generations, would also be lost, further erasing an important part of human history and culture. Meanwhile, the global economy would continue to suffer. Agriculture, tourism, and industries that relied on Amazonian plants and minerals would be forced to adjust to a world without them. Many products that people take for granted, such as coffee, chocolate, and medicinal plants, would become scarce or much more expensive. The pharmaceutical industry, which relies on compounds found in the Amazon, would struggle to find replacements for certain medicines, potentially delaying medical advancements and treatments. As the months pass, it would become clear that life on Earth has permanently changed. The Amazon rainforest had provided stability to global ecosystems for millions of years, and now its absence would be felt in every corner of the planet. In Part 4, we'll explore what the world might look like in the years that follow and whether humanity would be able to adapt to this new reality. Years after the Amazon rainforest has completely burned down, the world has been forced to adapt to a reality shaped by its loss. The environmental, social, and economic effects have only deepened, leaving behind a planet that is less stable, less predictable, and far more difficult to live in. By this point, global temperatures have risen significantly. Without the Amazon's ability to store carbon, greenhouse gas levels have continued to climb, intensifying the effects of climate change. Entire regions that were once habitable are now suffering from extreme conditions. The Arctic has seen record ice melt, causing sea levels to rise even faster. Coastal cities, including major economic hubs, have been forced to build costly infrastructure to hold back the ocean. Some areas have become completely uninhabitable, displacing millions of people. This has created a global refugee crisis, as populations are forced to migrate to places that are already struggling to support their own citizens. The weather has become even more erratic, storms are stronger, droughts are longer, and wildfires have become more frequent worldwide. The loss of the Amazon disrupted global rainfall patterns, and this effect has only worsened over time. Crops that once thrived in certain areas no longer grow, forcing farmers to find new land or abandon their trade altogether. Food shortages are becoming common, and the cost of basic necessities has skyrocketed. Countries that depended on consistent rainfall from the Amazon, particularly in South America, now suffer from repeated crop failures. In many parts of the world, fresh water is becoming more difficult to access. The Amazon played a crucial role in regulating the global water cycle, and its absence has left reservoirs and groundwater supplies shrinking. Some of the rivers that relied on its constant moisture have dried up, leaving communities without a reliable water source. Water disputes have become more frequent, leading to tensions between nations that are competing for what little remains. Some regions have resorted to expensive desalination efforts, but these solutions are not enough to meet the growing demand. Biodiversity loss has also reached a critical point. With the Amazon gone, thousands of species have gone extinct, while many others struggle to survive in a world without their native habitat. The loss of these animals and plants has caused unexpected ripple effects. Certain insect populations have exploded due to the lack of natural predators, leading to problems in agriculture and public health. Meanwhile, pollinators like bees and butterflies have declined, making food production even more difficult. The damage to the natural world is something that cannot be undone, and scientists warn that we are in the midst of an irreversible mass extinction event. Economically, the world has struggled to adjust. The industries that once relied on the Amazon's resources, such as pharmaceuticals and agriculture, have been forced to find alternative solutions. However, many of these replacements are costly and less effective. The sudden disappearance of key crops and medicinal plants has changed global markets, making everyday products much more expensive. Countries that once benefited from the Amazon's tourism industry have suffered major financial losses, as there is nothing left to attract visitors. The once thriving ecotourism sector has completely collapsed. Beyond the tangible effects, there is also a sense of loss that cannot be measured. The Amazon was a natural wonder, home to incredible biodiversity and cultures that had existed for thousands of years. Its disappearance has left a hole in the planet's identity, reminding humanity of what was lost due to short-term greed and negligence. While reforestation efforts have been attempted, the scale of destruction has made it nearly impossible to restore what was lost. The ecosystem that once existed in the Amazon took millions of years to develop, and even with the best efforts, it would take thousands of years to regain anything close to what was once there. As the years pass, scientists, environmentalists, and leaders look back at the loss of the Amazon as one of the greatest environmental disasters in history. The warnings were there, the consequences were clear, and yet humanity allowed it to happen. Now future generations are left to deal with the consequences of a world that is hotter, drier, and more unstable than ever before. The question that remains is whether humanity will learn from this disaster and take action to protect the remaining forests and ecosystems that still exist. If not, the loss of the Amazon may only be the beginning of a much larger catastrophe. Imagine you wake up in the middle of the night, look out your window, and realize something is missing. The moon, the glowing celestial body that's always been there, is gone. It's not just a bad dream. The moon has actually drifted away from Earth, and not just a little, but drastically, overnight. What would happen if the moon suddenly disappeared like that? First, let's talk about how the moon is moving away from Earth, and how it's been happening slowly for millions of years. Every year, the moon drifts about 1.5 inches farther from Earth. That's not a huge distance, but it adds up over time. This might seem like something far off in the future, but if the moon were to drastically leave Earth in a short period of time, the effects would be immediate and intense. The moon plays a massive role in Earth's natural systems. It's the main reason we have tides, for one. The gravitational pull of the moon on Earth causes the ocean tides to rise and fall. The closer the moon is, the stronger the pull, but if it moved away quickly, we'd see a huge change in the tides. Without the moon's gravitational pull, Earth's tides would become much weaker. The high and low tides we're used to would become barely noticeable. This would dramatically affect coastal ecosystems, especially in areas where marine life depends on the constant flow of the tides, Animals that rely on the tidal movements to breed, find food, or migrate could struggle to survive. In addition to the impact on tides, the moon's sudden departure would affect Earth's rotation. Right now, the moon helps to slow down Earth's spinning, keeping the planet's rotation at a consistent pace. Without the moon, Earth would start spinning faster. This might sound like a good thing, but it would mean that days would get shorter. Imagine trying to adjust to a day that's only 10 hours long. It would be incredibly difficult for life on Earth to adapt to such drastic changes in a short time. Plus, the absence of the moon's gravitational pull would cause Earth's rotation to become more erratic, leading to even more instability. But there's more. The moon also helps to stabilize the tilt of Earth's axis. This tilt is what causes the changing seasons, and without the moon, Earth's tilt could become more unpredictable. Over time, this would result in extreme shifts in climate. There could be periods of intense cold, followed by unbearable heat. The stability we take for granted in the weather patterns would be shattered, making life incredibly difficult to sustain. As you can see, the moon's role in stabilizing Earth's environment is huge. If it were to drift away drastically overnight, the effects would be immediate and catastrophic. The tides would weaken, days would shorten, and our planet's climate would become unstable. But these are just the beginning of the problems we would face. In the next part, we'll dive deeper into how these changes would affect life on Earth and what could happen to our planet if the moon continued to drift further away. Now that we've seen what would happen if the moon disappeared overnight, let's explore how these changes would ripple through Earth's environment and what impact they would have on life. One of the most immediate effects would be the loss of the stabilizing influence the moon has on Earth's axial tilt. Earth's axis, which is currently tilted at about 23.5 degrees, is responsible for the changing seasons. This tilt keeps the planet's climate relatively stable and allows for the diverse ecosystems we have today. Without the moon, the Earth's axial tilt could start to wobble, shifting between extremes. Over time, this would lead to wild and unpredictable seasons. Some parts of the world could experience scorching heat for extended periods, while others could face ice ages. These sudden and extreme changes would make it difficult for most forms of life to survive, as plants and animals would struggle to adapt to such dramatic shifts in climate. But the moon's absence wouldn't only affect the weather, the oceans would also be heavily impacted. The moon's gravitational pull is what creates the tides, and without it, Earth's oceans would behave very differently. Right now, we have regular, predictable tides, high tides and low tides that are caused by the moon's pull. Without this force, those tides would almost vanish. This would be devastating for the coastal ecosystems that rely on these regular changes. Coral reefs, estuaries, and beaches are all shaped by tidal forces, and without them, many species of marine life could disappear. The changes to the tides would also lead to the erosion of coastlines. Areas that were once protected by regular tidal movements would see a loss of land, with beaches and shores being washed away. But the impacts don't stop there. The moon also has a key role in regulating the length of our days. While the moon is slowly drifting away from Earth, it actually has the opposite effect on our planet's rotation. The moon helps to slow Earth's spin over time. Without it, Earth's rotation would start to speed up. This could mean shorter days, perhaps just 10 hours long or even less. Imagine how strange it would feel to experience such a dramatic change in the length of a day. Plants and animals have evolved to live in a rhythm tied to the Earth's current 24-hour cycle. With days becoming shorter, life forms would be thrown off balance. The natural processes that depend on the timing of day and night, like flowering plants, animal migration, and human sleep cycles, would be disrupted. Another consequence of the moon's absence would be the loss of its protective role. The moon helps to shield Earth from space debris. Its gravity has a kind of shielding effect, deflecting or capturing small asteroids and comets that might otherwise impact Earth. Without the moon, Earth would become much more vulnerable to collisions with space objects. The risk of asteroid impacts would increase, which could lead to more frequent and larger impacts on our planet. The larger the asteroid, the more catastrophic the effect. We could see massive craters, fires, and even the potential for a mass extinction event if a large enough asteroid struck Earth. These changes would all happen over time, but they would significantly alter life on Earth. The loss of the moon would throw off the delicate balance that has allowed life to thrive. It's clear that without the moon, our planet would face unpredictable climate shifts, disappearing coastlines, shorter days, and a higher risk of catastrophic space impacts. While the effects would take time to unfold, the question remains, could humanity adapt to these changes, or would it become too difficult to survive on a moonless Earth? Next part, we'll take a closer look at how this moonless world could impact not just nature, but humanity itself. Would we be able to survive the dramatic changes, or would our planet become uninhabitable? As we imagine a moonless world, it's crucial to consider how humans would cope with these drastic changes. The loss of the moon would affect not only the environment, but also our everyday lives in ways we might not immediately think about. Our civilization relies heavily on the natural rhythms of Earth, and with the moon gone, those rhythms would no longer be the same. One of the first major challenges would be the shift in how we measure time. Right now, we track time based on the Earth's rotation and the cycle of the moon. The moon's influence on Earth's tides and rotation plays a role in keeping our calendar and daily schedules predictable. With the moon's absence, Earth's rotation would start to speed up, shortening the length of a day. This might seem like a minor change, but it would throw off everything from work schedules to agriculture. Farming in particular depends on the consistent cycles of day and night. Without the steady rhythm of the moon's influence, crops might not grow as they once did. Plants that rely on the 24-hour cycle would have to adapt to a much shorter day. And that's no simple task. This could lead to crop failures, food shortages, and an uncertain future for global agriculture. Humans, too, would have to adjust to the new length of the day. Our bodies are finely tuned to a 24-hour cycle known as the circadian rhythm. This rhythm governs everything from sleep patterns to hormone production. Shorter days would disrupt this natural rhythm, leading to sleep disorders, fatigue, and increased stress. Over time, we would likely try to adjust, but the change could take generations. Even with technology and artificial light, the biological impact would be profound, and our overall health could suffer. Another unexpected effect would be the loss of the moon's impact on human culture and psychology. Throughout history, the moon has played a central role in our stories, myths, and traditions. From ancient cultures to modern times, the moon has been a symbol of everything from love and mystery to time and fate. Without it, the psychological impact on humanity could be more significant than we realize. The moon's absence might leave a void in our collective consciousness, affecting everything from art to religion. People might begin to feel an existential emptiness, as the night sky would no longer feature that familiar calming glow. Imagine staring up at the sky, night after night, and seeing nothing where the moon once was. It could lead to a loss of connection to the cosmos, and possibly even a deeper sense of isolation. The absence of the moon would also affect human navigation. For centuries, sailors have used the moon, along with the stars, to guide them across the oceans. Without the moon, navigation by natural means would become much more difficult. Though we rely on technology now, the moon has always been a reliable fixture in the night sky, guiding travelers and explorers. The sudden disappearance of this celestial body would leave a vast empty space in the sky, making it more difficult for people to orient themselves in unfamiliar places, particularly during the night. The way we understand the passage of time would also be altered. Many ancient cultures used lunar calendars, which rely on the phases of the moon to track the months. These calendars would no longer be useful, forcing humanity to adapt and come up with entirely new systems to measure time. The moon's absence would be felt in our celebrations, holidays, and the way we organize society. Festivals like Easter, which are based on the lunar cycle, would lose their connection to the moon, and entire cultural traditions could change or disappear. It might seem like a small thing, but the loss of such a deeply ingrained symbol of time would affect society in ways that are hard to predict. Humanity's technological capabilities would be tested in this moonless world. While we have the technology to survive extreme environmental conditions, the global disruptions caused by the loss of the moon could overwhelm even the most advanced systems. Agricultural and health systems would face new challenges that we aren't currently prepared for. With extreme weather events becoming more frequent due to the instability of Earth's axis, infrastructure would need to be adapted to deal with the unpredictable climate. We would also need to develop new ways to protect against the increasing risks from space debris, as the moon's absence would leave us more vulnerable to asteroid impacts. The potential for devastating impacts from space could push us to further explore space technology and asteroid defense systems, but the cost of these endeavors would be enormous. As we can see, the loss of the moon would lead to profound changes for humanity. From agriculture and health to culture and technology, our lives would be forever altered. The absence of the moon would create a world that feels unfamiliar, where the natural rhythms that have shaped human existence for centuries no longer apply. But the question remains, could we adapt to this new world? Would humanity be able to survive without the moon, or would the changes be too overwhelming to handle? In the next part, we'll explore the long-term effects of a moonless Earth and how life as we know it could evolve, or struggle to survive, in this drastically altered world. In this moonless world, the long-term survival of life on Earth would be one of the most pressing concerns. With the moon's stabilizing influence completely gone, Earth's future would become increasingly uncertain. While some species might adapt to the new environment, the effects of the moon's departure would ripple through ecosystems, and the survival of life on Earth would face serious challenges. First, let's consider the impact on the planet's climate. The moon plays a key role in stabilizing Earth's axial tilt, preventing drastic fluctuations in the planet's climate over long periods of time. Without the moon, Earth's axis would become more unstable. Over thousands of years, this instability could cause significant changes in global temperatures and seasons. We might experience extreme shifts in climate, where some regions become much hotter while others grow colder. This would lead to new and unpredictable weather patterns, making agriculture, food production, and the basic foundations of society much harder to maintain. Some areas could become inhospitable, forcing large-scale migrations of humans and animals in search of more livable climates. This shift in climate would likely cause massive disruptions in ecosystems. Plants and animals have evolved in ways that depend on relatively stable climate conditions. If temperatures were to fluctuate drastically, many species might not be able to survive. The loss of certain species could cause cascading effects throughout ecosystems, where the extinction of one species triggers a chain reaction that impacts others. For example, without the moon's influence on the tides, ocean currents would change, affecting marine life and ecosystems that depend on consistent water temperatures and nutrient levels. Species that rely on predictable weather patterns, such as migratory birds, could face difficulties in finding the right habitats. In this new world, Earth's biodiversity would be severely threatened. In terms of human survival, the challenges would be immense. The immediate effects on agriculture would be catastrophic. As mentioned earlier, the shifting day length and disrupted circadian rhythms would create chaos in farming systems. Crops that rely on a 24-hour cycle of day and night would struggle to grow in a world where days are constantly changing. This would lead to widespread food shortages, as farmers would not be able to produce enough food to sustain the global population. With unpredictable weather patterns and changes in rainfall, irrigation systems would fail, and many regions could face droughts or floods. The future of global agriculture would need to be reimagined to deal with the new hostile environment. Human health would also be at risk. With the loss of the moon's gravitational influence, the Earth's crust would become more unstable. Without the moon's stabilizing effect, we might experience an increase in seismic activity such as earthquakes and volcanic eruptions. These events could cause widespread damage to infrastructure and threaten entire communities. The health of the population would also be affected by the lack of stable sleep cycles. As our circadian rhythms become disrupted, sleep disorders would become more common and stress levels would rise. Over time, these health issues could weaken the overall resilience of humanity, making it harder to cope with the challenges ahead. In the long run, the disappearance of the moon could also lead to the eventual destabilization of Earth's orbit. Without the moon's gravitational influence, Earth would become more vulnerable to asteroid impacts. These impacts, while rare, could have catastrophic effects on life. The moon has long acted as a shield for Earth, absorbing some of the blows from space debris that would otherwise strike our planet. With the moon gone, Earth would be more exposed to the dangers of space. This increased risk of asteroid impacts would make the Earth a more dangerous place to live, further complicating humanity's survival. Despite these challenges, life on Earth might continue in some form. Over thousands of years, certain species could adapt to the new conditions, while others might evolve to thrive in the moonless world. However, for humanity, this new world would be incredibly harsh. Survival would depend on our ability to adapt quickly to the changing environment and find ways to maintain food production, health, and stability in the face of constant upheaval. We would likely need to turn to technology to solve many of these problems, from developing new ways to produce food to building infrastructure capable of withstanding extreme weather and seismic activity. In conclusion, the moon's departure from Earth would have far-reaching consequences for life on our planet. While some species might adapt, humanity would face a long, difficult struggle to survive. Climate shifts, agricultural breakdowns, health issues, and the increased risk of asteroid impacts would all combine to create a world that is much less hospitable than the one we know today. Our ability to survive in such a world would depend on how quickly we could adapt and how well we could use technology to counteract the challenges that arise. Ultimately, the loss of the moon would reshape Earth in ways we can't fully predict, leaving us with a stark reminder of how interconnected our world is with the celestial forces that govern it. Imagine waking up one morning and taking a deep breath, only to find that the air feels different. It's crisper, almost electric, like every breath fills your lungs with an overwhelming amount of energy. That's because in this scenario, the oxygen levels on Earth have suddenly doubled. It sounds exciting, but would this be a good thing, or would it send the planet into complete chaos? Oxygen is crucial for life on Earth, making up about 1/5 of our atmosphere. But if that amount were to double, it wouldn't just mean fresher air. The entire balance of life on our planet would shift in ways that might seem like something out of a sci-fi movie. For starters, fire would become an immediate and uncontrollable threat. Right now, fires need fuel, heat, and oxygen to burn. With twice as much oxygen in the air, even the smallest spark could turn into an inferno within seconds. A dropped match, a lightning strike, or a simple short circuit could ignite massive fires, spreading faster and burning hotter than anything we've ever seen. Wildfires would become unstoppable, engulfing forests, grasslands, and even cities in flames that would be nearly impossible to put out. Firefighting methods that work today, like water and fire breaks, might not be enough in an oxygen-rich world. But it's not just fires that would change. Human bodies would feel the effects almost immediately. More oxygen might sound like a good thing, but our lungs and bloodstream are built to handle a very specific level of it. Doubling the oxygen could overload our system, leading to a condition called oxygen toxicity. This would cause dizziness, nausea, and confusion at first, but in extreme cases, it could lead to seizures and even lung damage. Athletes might feel an initial boost in energy and endurance, but over time, their bodies would struggle to handle the excess oxygen, leading to long-term health complications. Animals would also be affected, and the impact would vary depending on their size and biology. Smaller creatures like insects would likely thrive in an oxygen-rich world. In prehistoric times, when oxygen levels were higher than they are today, some insects grew to enormous sizes. Dragonflies with wingspans as wide as an eagle's, and millipedes longer than a person. If oxygen levels doubled, we might start seeing something similar again, with bugs growing far larger than what we're used to today. Larger animals, however, would have a harder time adapting. Many species have evolved to function with a precise amount of oxygen, and doubling it could throw off their entire metabolism. Some animals might become hyperactive, their bodies using the extra oxygen to produce more energy. Others could suffer from oxidative stress, damaging their cells and organs. The natural balance of predator and prey could be completely thrown off, causing ripple effects across entire ecosystems. Even the weather wouldn't stay the same. The increased oxygen levels would change the way the atmosphere interacts with sunlight and moisture, potentially leading to more intense storms. Lightning strikes could become more frequent, triggering even more fires. The sky itself might look different, possibly a deeper, more vibrant blue due to the way light scatters through the atmosphere. This is just the beginning of how a world with doubled oxygen would unfold. The effects would spread far beyond our own bodies and into the natural world in ways we might not expect. As we continue, we'll dive deeper into how plant life, ocean ecosystems, and even evolution itself would change in this strange new reality. With fires raging out of control and animals struggling to adapt, the natural world would be in chaos. But what about plants? You might think that doubling the oxygen in the air would supercharge plant life, making forests greener and crops grow faster. However, the reality is much more complicated. Plants don't rely directly on oxygen for growth. They depend on carbon dioxide for photosynthesis. With more oxygen in the atmosphere, plants might actually struggle to take in enough carbon dioxide, slowing down their ability to produce energy. Some species could adapt and grow larger, while others might become stunted or even start to die off. This would throw entire ecosystems into disarray, as herbivores that rely on plants for food could suddenly face food shortages, leading to population crashes and mass starvation among certain species. But there's another issue: wildfires. In part 1, we talked about how increased oxygen would make fires burn hotter and spread faster. Now imagine a world where plant life is growing at an accelerated rate, but also drying out just as quickly due to increased combustion risks. Even a minor spark could set off massive infernos, destroying entire forests before they have a chance to regenerate. The very thing that seems like a benefit, faster plant growth, would actually lead to more destruction. The oceans wouldn't be spared from these changes either. Right now, the balance of oxygen in the ocean is carefully maintained by marine plants and phytoplankton, which produce much of the oxygen we breathe. If oxygen levels in the air doubled, that balance would shift dramatically. Some marine creatures, like certain fish and crustaceans, would struggle to adapt, while others, particularly bacteria that thrive in high oxygen environments, could take over. This could lead to massive changes in the ocean's food chain, potentially causing some species to boom in population, while others vanish entirely. And then there's evolution. Throughout history, life on Earth has adapted to changing environments, but never at a rate as extreme as this. With increased oxygen, animals might start evolving faster, developing stronger muscles, higher energy levels, and even changes in their respiratory systems to cope with the new conditions. Some creatures could grow larger, much like the giant insects of prehistoric times, while others might develop new ways to use the excess oxygen to their advantage. But this rapid evolution wouldn't just affect animals, it could also impact humans. Over generations, people might develop stronger lungs, increased endurance, or even a different metabolism to handle the higher oxygen levels. However, in the short term, the sudden shift in oxygen could lead to widespread health crises as human bodies struggle to adapt. Hospitals would see a surge in patients dealing with oxygen toxicity, and long-term exposure could lead to permanent damage to our cells and organs. All of these changes would happen at an alarming rate, altering the planet in ways we can't fully predict. But what about the long-term consequences? Could Earth eventually settle into a new balance? Or would this shift lead to an unstoppable chain reaction of disasters? In part 3, we'll explore how human civilization itself would be affected, everything from infrastructure and industry to technology and daily life in this high oxygen world. With nature struggling to adapt and ecosystems facing rapid change, what would life be like for human civilization? The effects of doubled oxygen levels wouldn't just impact our health, it would reshape industries, technology, and even the way cities function. One of the first major changes would be seen in infrastructure. Many of the materials we rely on, such as steel and concrete, undergo oxidation over time, but with twice as much oxygen in the air, corrosion would happen at an accelerated rate. Bridges, buildings, pipelines, and other structures would weaken faster, leading to an increase in maintenance costs and a higher risk of structural failures. Airplanes, ships, and vehicles would also degrade more quickly, making travel and transportation far more dangerous. Factories and power plants would also face new risks. Many industrial processes involve combustion, and with more oxygen available, explosions would become far more frequent and intense. Welding, fuel storage, and even something as simple as lighting a gas stove could become life-threatening if safety measures weren't drastically improved. Fire departments worldwide would have to develop new strategies and technologies just to keep up with the increased number of fires and industrial accidents. But what about energy production? Interestingly, some forms of renewable energy might benefit from the change. Wind turbines could generate more power as oxygen-rich air is denser, allowing for stronger wind currents. However, this benefit would be overshadowed by the challenges in other energy sectors. Fossil fuel power plants would need extensive modifications to handle the increased risk of fire and explosions, and nuclear power facilities might also require new cooling systems to prevent overheating caused by changes in atmospheric pressure and combustion efficiency. Speaking of combustion, the increased oxygen levels would have a significant impact on fuel efficiency. Vehicles that rely on internal combustion engines would burn fuel more efficiently, increasing horsepower and speed. However, this would also mean that accidents would be more severe, as vehicles would have more explosive potential and higher velocities. Car manufacturers would need to redesign engines, braking systems, and safety features to compensate for these changes. On a smaller scale, even daily activities would become riskier. A simple campfire or barbecue could get out of control instantly. Smoking a cigarette could be deadly if the increased oxygen made it burn too hot or too fast. Households would need fireproofing measures just to prevent everyday mishaps from turning into major disasters. Aside from the physical dangers, human society would face a psychological and social shift. The rapid pace of change, both in the environment and in the way we live, could cause widespread panic and instability. Governments would need to impose strict regulations on industry, energy use, and construction to prevent catastrophic failures. Emergency services would be overwhelmed with an increase in fire-related disasters, structural collapses, and health crises related to oxygen toxicity. The financial burden would be enormous. Insurance companies would see a spike in claims due to property damage, fires, and industrial accidents. The costs of maintaining cities and infrastructure would skyrocket, leading to potential economic downturns as governments struggle to keep up. Entire industries might collapse if they can't adapt quickly enough, while new technologies and businesses could emerge to meet the new demands of this high-oxygen world. But with so many risks, could there be any advantages for human civilization? In Part 4, we'll explore the long-term effects, how humanity might adapt, the future of evolution, and whether society could ever stabilize in this extreme new environment. With so many immediate dangers and rapid changes, humanity would be forced to adapt or face disaster. But what would life look like in the long run? Could civilization stabilize in a world with double the oxygen? One of the biggest shifts would be in human biology. Over generations, our bodies would begin to evolve to handle higher oxygen levels. While initial exposure might cause oxygen toxicity, long-term survival could favor individuals with genetic mutations that allow for better oxygen regulation. Future humans might have altered lung structures, changes in blood composition, or even a different metabolic rate. This could lead to longer lifespans, enhanced physical abilities, and a reduction in certain diseases. But it could also bring new health challenges we can't yet predict. With a faster evolutionary pace, the animal kingdom would also undergo massive changes. Some species might shrink to reduce oxygen intake, while others could grow larger, similar to the prehistoric giants that thrived in high oxygen environments. Insects in particular could see a dramatic size increase. Massive dragonflies, enormous beetles, and oversized spiders could become common, reshaping ecosystems in unpredictable ways. Cities and technology would also be forced to evolve. The materials we use would need to be more resistant to corrosion and fire, leading to the development of new alloys, fireproof coatings, and entirely different methods of construction. Some societies might even move toward underground cities or climate-controlled domes to protect themselves from the unstable environment above. Industries that rely on controlled combustion, such as manufacturing and energy production, would be completely reworked. Safer, non-flammable energy sources would become a priority, pushing the rapid advancement of nuclear fusion, geothermal energy, and alternative methods of transportation. Fossil fuels might become obsolete, as burning them in a high-oxygen world would be far too dangerous. Farming and food production would also undergo significant changes. Crops would grow larger and faster, potentially solving food shortages, but with that growth would come new challenges. More plant life means a higher demand for nutrients, leading to soil depletion and the need for enhanced agricultural techniques. Farmers would need to adapt quickly to prevent ecosystems from becoming overwhelmed by aggressive plant species. With new dangers and opportunities, human society might become more divided. Some regions could embrace technological advancements, building ultra-safe, fire-resistant cities with controlled atmospheres. Others might struggle to keep up, leading to economic and social instability. Governments would likely impose strict environmental and industrial regulations, creating a world where safety measures dictate everyday life. Despite all the chaos, humanity has a history of resilience. If we could survive the initial period of instability, we might eventually reach a point where life in a high-oxygen world feels normal. It wouldn't be the same Earth we know today. Fires would remain a constant threat. Creatures would look different, and even the air we breathe would have long-term effects on our bodies. But civilization could still find a way to thrive. In the end, doubling the oxygen on Earth would be a double-edged sword. It could lead to incredible advancements in a new era of evolution, but only if we can overcome the extreme dangers that come with it. One thing is clear: the delicate balance of our atmosphere is something we shouldn't take for granted. What do you think? Would you want to live in a world with twice the oxygen? Let me know in the comments. And if you enjoy exploring mind-bending scenarios, check out my next video, where I dive into another wild what-if question.